Welcome to the Huberman Lab podcast, where we discuss science and science-based tools for everyday life. I'm Andrew Huberman, and I'm a professor of neurobiology and ophthalmology at Stanford School of Medicine. My guest today is Dr. Brian Keating. Dr. Brian Keating is a professor of cosmology at the University of California, San Diego. Today's discussion is perhaps the most zoomed out discussion that we've ever had on this podcast. What I mean by that is today we talk about the origins of the universe. We talk about the Earth's relationship to the sun and to the other planets. We talk a lot about optics, so not just the neuroscience of vision and our ability to see things up close and far away, but to see things very, very far away or very, very close up using telescopes or microscopes, respectively. So today's discussion is a far-reaching one, literally and figuratively, and one that I know everyone will appreciate because it really will teach you how the scientific process is carried out. It will also help you understand that science is indeed a human endeavor, and that much of what we understand about ourselves and about the world around us, and indeed the entire universe, is filtered through that humanness. But I want to be very clear that today's discussion is not abstract. You're going to learn a lot of concrete facts about the universe, about humanity, and about the process of discovery. In fact, much of what we talk about today is about the process of humans discovering things about themselves and about the world. Dr. Keating has an incredible perspective and approach to science, having built, for instance, giant telescopes down at the South Pole and having taken on many other truly ambitious builds in service to this thing we call discovery. Before we begin, I'd like to emphasize that this podcast is separate from my teaching and research roles at Stanford. It is, however, part of my desire and effort to bring zero-cost-to-consumer information about science and science-related tools to the general public. In keeping with that theme, this podcast episode does include sponsors. And now for my discussion with Dr. Brian Keating. Dr. Brian Keating, welcome.
Dr. Andrew Huberman, it's great to meet you in person finally. I thought you were a legend.
I exist in real life, and you do as well. And I'm delighted that we're going to talk today because I have a long-standing adoration, there's no other appropriate word, for eyes, vision, optics, the stars, the moon, the sun. I mean, animals, humans. What's more interesting than how we got here and how we see things and what we see and why?
That's right.
You're a physicist. You're a cosmologist, not a cosmetologist.
That's right. I do hair and makeup if you're interested.
Please orient us in the galaxy.
So I get to study, the entire universe basically. And it's not really such a stretch that cosmetology and cosmology share this prefix because the prefix cosmos is what relates those two words together that seem to be completely, unrelated to each other, right? But it turns out the word cosmos in Greek, the etymology of it, is beautiful or appearance. So we have a beautiful appearance, we look a certain way, we're attracted to certain things. But it kind of reflects the fact that the night sky is also beautiful, attractive, and evokes something viscerally in us. We humans are born with two refracting telescopes in our skulls, embedded in our skulls. And as you point out, the retina's outside the cranial vault, right? I'll never forget you saying that. That means we have astronomical detection tools built into us. We don't have tools to detect the Higgs boson built into us or to look at a microscopic virus or something like that. So astronomy is not only the oldest of all sciences, it's the most visceral one. So it connects us. And of the sciences, of that branch of science, of astronomical sciences, cosmology is really the most overarching. It really includes everything, all physical processes that were involved in the formation of matter, of energy, maybe of time itself. And it speaks to a universal urge, I think, to know what came before us. Like I always ask people, I'll ask you, I know what the answer is probably, but what's your favorite day on the calendar?
Favorite day on the calendar?
Yeah.
I love New Year's Day.
New Year's Day, exactly. What is that? It's a beginning. It's a new. Some people say their birthday, their kid's birthday, if they're smart, their anniversary, right? You don't want to get too out of control with the misses. What are those? Those are beginnings. What's the only event that no entity could even bear witness to? The origin of the universe. And I think that speaks to something primal in human beings that are curious, at least. We want to uncover the secrets of what existed, what came before us. And we don't have any way of seeing that currently. So we have to use the fossils that have made their way throughout all of cosmic time to understand what that was like at the very beginning of time, and perhaps maybe about the universe as it existed before time itself began. So to me, it's incredibly fascinating. It encompasses all of science in some sense. It even can include life on other planets, consciousness, the formation of the brain. And to me, I'm always interested in the biggest questions. And the biggest topics that evoke curiosity in me is, how did it all get here? And so that's what cosmology allows us to do, apply the strict, exacting laws of physics to a specific a domain, which is the origin of everything in the universe. That's what makes it so fascinating.
I'd like to take a quick break and acknowledge one of our sponsors, LMNT. LMNT is an electrolyte drink that has everything you need, but nothing you don't. That means the electrolytes, sodium, magnesium, and potassium, all in the correct ratios, but no sugar. Proper hydration is critical for optimal brain and body function. Even a slight degree of dehydration can diminish cognitive and physical performance. It's also important that you get adequate electrolytes. The electrolytes, sodium, magnesium, and potassium, are vital for the functioning of all the cells in your body, especially your neurons or your nerve cells. Drinking LMNT dissolved in water makes it extremely easy to ensure that you're getting adequate hydration and adequate electrolytes. To make sure that I'm getting proper amounts of hydration and electrolytes, I dissolve 1 packet of LMNT in about 16 to 32 ounces of water when I wake up in the morning, and I drink that basically first thing in the morning. I also drink LMNT dissolved in water during any kind of physical exercise that I'm doing, especially on hot days when I'm sweating a lot and therefore losing a lot of water and electrolytes. They have a bunch of different great tasting flavors of LMNT. They have watermelon, citrus, etc. Frankly, I love them all. And now that we're in the winter months in the Northern Hemisphere, LMNT has their chocolate medley flavors back in stock. I really like the chocolate flavors, especially the chocolate mint when it's heated up, so you put it in hot water. And that's a great way to replenish electrolytes and hydrate, especially when it's cold and dry outside, when hydration is especially critical. If you'd like to try LMNT, you can go to drinklmnt.com/Huberman to claim a free LMNT sample pack with the purchase of any LMNT drink mix. Again, that's drinklmnt.com/Huberman to claim a free sample pack. Today's episode is also brought to us by BetterHelp. BetterHelp offers professional therapy with a licensed therapist carried out entirely online. I've been doing weekly therapy for well over 30 years. Initially, I didn't have a choice. It was a condition of being allowed to stay in school. But pretty soon I realized that therapy is an extremely important component to overall health. In fact, I consider doing regular therapy just as important as getting regular exercise, including cardiovascular exercise and resistance training, which of course I also do every week. There are essentially 3 things that great therapy provides. First of all, it provides a good rapport with somebody that you can trust and talk to about all issues that you're concerned about. Second of all, it can provide support in the form of emotional support or directed guidance. And third, expert therapy can provide useful insights. With BetterHelp, they make it very easy to find an expert therapist with whom you resonate with and can provide those benefits that come through effective therapy. Also, because BetterHelp allows therapy to be done entirely online, it's very time efficient. It's easy to fit into a busy schedule. There's no commuting to a therapist's office or sitting in a waiting room or anything like that. You simply go online and hold your appointment. If you would like to try BetterHelp, go to betterhelp.com/Huberman to get 10% off your first month. Again, that's betterhelp.com/Huberman. Before we get to the origins of the universe and the organization of the planets relative to the sun and their spins, etc., you said something that, at least to me, feels intuitively so true, and I think it's very likely to be true for everybody, which is that there's something about looking up into space, especially at night when we see the stars and hopefully see the stars. We'll talk about light pollution a little bit later. When we see the stars, that yes, we know these things are far away. Yes, we know that they occupy a certain position in space. They have a diameter, etc. We might not know what that is just by looking at them. You probably do. But they also change our perception of time. And, if I were to say one thing about the human brain especially is that, sure, it's got all these autonomic functions. It regulates heart rate, digestion, etc., sleep-wake cycles. It can remember. It can think. It can have states like rage or anger or happiness or delight. But what's remarkable about the human brain is that it can think into the past, it can be quote unquote present, and it can project into the future. And I'm sure other animals can do that, but we do this exquisitely well, and we make plans on the basis of this ability to contract or expand our notion of time. As a non-biologist, but somebody who I think appreciates and understands biology, why do you think it is that when we look up into the sky, even though most people might not realize that those stars probably aren't there and occupying the position that we think they are, some of them probably are, some of them aren't, they existed a long time ago, but without knowing that, why do you think that looking up at the stars gives us the sense of an expansion of time as opposed to just the expansion of space?
Well, first of all, we have to take ourselves back, to deep prehistory. We know that ancients were looking at the constellations because they were seemingly either in control of or correlated with or perhaps causative of the seasons. And that was of divine importance, supreme importance for them, right? Their whole existence in early agrarian societies, hunting societies, gathering societies. So they had to know about time. So time, the essence of time, and that on large scale for seasons, for holidays, for festivals, for propitiation of deities and so forth, they had to keep track of it. And that's why in the caves in Lascaux that date back to the 40,000 BCE, they depict constellations: Orion, the hunter, Taurus, the bull, all these different constellations. They depict them there. Now, partially that was because Netflix didn't exist back then, right? There was no TikTok, and so there wasn't much to do at night. And in fact, the more you were out at night, you probably increased your opportunity to be consumed by some predator, right? So you were more focused on being stationary, observing. And as I said, we can do astronomy uniquely so amongst all the sciences with just the equipment we're born with, measurements with our eyes with respect to landmarks to calculate patterns. And humans are exceptionally good at recognizing patterns, sometimes too good.
So for instance, knowing that a certain swath of stars is present at one time of year and not another relative to, say, the contour of a mountain ridge.
Yes, and the repetition of it over and it passed down through generations. Before there was written language, there was pictography, there was the cave paintings and so forth. There was oral language, and that was it. For written language is only 10,000 years old or something like that. So to store information, that meant it was a continuity between generations. My great-great-great-grandfathers, elders, whatever, taught me that when the moon is in this constellation, the sun is in this constellation, we should plant or we should harvest in other times. And so it was, we still do use the rotation of the Earth. Hasn't changed that much since this 40,000 year period, right? I mean, the axis in which it rotates, that's a different story. But the actual spin rate, the angular momentum of the Earth has not appreciably changed that much. And so the positions of these objects were of such importance that the ancients would use them for all these purposes. But there were so few things that changed position that they actually had names for them. They're called planets. So planet in Greek, it's like the word plane, like airplane. It means something that moves or wanders. So when you name something, it means it's pretty different from the other things in which are not associated with that characteristic. So the planets, there were only 5 that they could see at that time, up to Saturn. And they actually would associate those not only with astronomical events, but events down on Earth. That's what connected the Earth. So we have legacy of that in our calendar today. So Sunday, named after the sun. Monday, moon. Tuesday, and you go to the Latin languages, I think it's Mercury, which is Mercury Day. Ventre, Venus Day, so you go to the Romance languages. And then the only one that's not a Latin name is, of course, for Thor, the god Thor, Thursday. And then it comes back Saturn Day, Saturday. So they were all used as a clock. And people don't really grasp this. I mean, we have an Apple Watch, we have whatever. We didn't have a clock that was functional, that would work on all different time zones and all different conditions on the pitching deck of a ship till the 1700s, basically. It was a huge problem. And so measuring time became crucial for commerce, for human culture and civilization to arise, for education, and obviously for planting, harvesting, and so forth. So there was an obvious connection between the two. They believed actually that they were causative, that actually the position of the planet Jupiter determined something on the day of your birth, and the sun's relative position with respect to it determined something about your future and your prospects in life and so forth. So when I'm not confused for a cosmetologist, because of my lovely hair and makeup, I'm usually asked, oh, you're an astronomer. I'm a Virgo. So what's going to happen to me? I'm like, I used to be, okay, that's an astrologer. I'm not an astrologer. But now I kind of lean into it. I'm like, ooh, that you're going to get a letter from the IRS next week, and that lump on your ass.
You're playing games with them?
Yeah.
So you don't believe in astrology?
There's no evidence for astrology. In fact, there's many random controlled trials, double-blind study that show not only is it's almost counter to the evidence. Like when they say that a monkey can throw a dart at a stock chart and get do better than most hedge fund managers or something like that. Actually, astrologers are even worse. Like I don't even know a protozoa could throw a dart. Yeah, it's almost anti-correlated, with what reality is. So no, there's certainly no validity to that. And I had a provocative tweet, post recently, and it was about there's actually we believe there are 12 zodiac signs. And that dates back to the Persians and the Babylonians and how they divided up them. And it almost divides, they were fascinated with the number 60. So that was the base of their number system. Our number system is 10 because we have 10 figures. For some reason, they love base 60. I don't know why. And so they love things that divide it evenly into it. 10 does, but anyway, hashtag fail for the Babylonians. But they divided it up into 12 zodiac signs. So we still use those. There's a problem, though. The zodiac do you know what this is? Do you know what determines your zodiac sign?
No.
Oh, okay. So it's determined by the position of the sun. What constellation was the sun in on the day you were born, September 26th? Mm-hmm. So that means that the sun was in the constellation Virgo. Oh, no, you were a Libra? Libra, okay. So you do know what you are, but you don't know why you are. So Libra means it's a constellation. There's 88 constellations that are accepted by astronomers, and the one of them is Libra. And the path that the sun and the moon and all the planets travel in is called the zodiac. It's confined to a plane because the same proto-solar system disk from which we formed out of, all the planets came out of a nebular cloud, a cloud of gas, dust, rocks, and so forth that came from a pre-existing star that exploded, creating what's called a supernova. The supernova provided the materials to make not only the Earth, but the entire solar system, including the sun. That happened about 5 billion years ago. And 4 billion years ago, the Earth formed out of that cloud. The spin of that disk, all things have a spin associated with them, like a figure skater, as she's spinning around on her axis or whatever, she can have her arms out, brings them in, she spins faster. That's called conservation of angular momentum. Spin is a type of angular momentum. The whole disk is spinning in a plane. It's like this desk, this table that we're sitting at. If you're listening, you imagine a flat table. It's spinning, a circular disk is spinning with a certain direction. All the objects are moving in that same direction due to conservation of this term called angular momentum. The sun apparently moves in that position. Obviously, we're rotating around the sun, but it looks like the sun's coming around us. The moon is, Jupiter. So on the day you were born, there's a constellation behind the sun from our perspective that was Libra on September 26th. And that was the day that you were born. That determines the fact that you're a Libra. But there's a problem. In December, where we are now, the sun is actually in a different constellation, the one that doesn't exist according to the zodiac that was created something like 5,000 years ago. It's called Ophiuchus. So there's a certain segment of people born in a 17-day stretch in December, late November to early December, that are actually Ophiuchans or Ophiuchuses or whatever. So that should obliterate astrology as any semblance of a science because they didn't even know this constellation existed, and yet something like 12% of all people share that constellation. So it's just complete nonsense. There's no validity to it. Twins that are born on the same day have radically different, histories, past, futures, and there's no predictive power to it. And that's what science is about, right? We want to make a hypothesis, test it, iterate on it, and have confirmation of it. And there's zero, in fact, for astrology. In fact, if you'll permit me a kind of silly story, when I was dating my wife, who would become my wife in the beginning, she kind of thought it's fun. Maybe we'll go see someone who can tell our fortunes. We belong together, so we went to an astrologer. And the astrologer asked me a bunch of questions. When were you born, obviously. And she asked me, what's your sign? So I said, I'm a Gemini. And she said, okay, cool. And then she told me a bunch of things. And at the end, I said, I just want to double check. I was playing, I'm kind of a little bit of a jerk sometimes. So I said, I just want to confirm. Gemini is born in September. I'm born September 9th. She said, oh, no, that's a Virgo. But the same things are going to happen to you anyway. Like it didn't change her outcome. And so in the language of the science, philosophy of science, Karl Popper, others, it's unfalsifiable. And you cannot be proven right. It's so flexible. You're going to find challenges. The stock market is going to fluctuate. Political turmoil will reign during they're so flexible, it can accommodate any story. And that's a hallmark of non-science or sometimes anti-scientific thinking.
One thing that really strikes me is the fact that, at least as the way you describe it, the first clock, the first timekeeping approach or mechanism was to evaluate the position of things in the sky relative to celestial landmarks.
Yeah.
So irrespective of when people are born in astrology, I could imagine a tribe of people, a group of people who have charts because they've, painted them onto some surface, doesn't matter what the surface is, that at some portion of the year, the stars are above this ridge. There are 3 bright stars above the ridge just to the left of the front of the village, so to speak. Like, this is not an unreasonable thing to imagine. And that information is passed down in the form of when those 3 stars are about to disappear behind that ridge, days are getting shorter. Whereas when those 3 stars are reemerging again elsewhere in the sky,
Yes.
days are getting longer. Forgive me, this will be a little bit of a long question. Sometimes the listeners get upset with me, but I think it'll frame it within the biology in a way that will be meaningful for us and for everyone. Other animals besides humans have this thing, the pineal gland, that secretes melatonin. The duration of melatonin release is directly related to how much light there is. In other words, light suppresses melatonin. Therefore, in short days, aka long nights, you get a lot more melatonin released. In long days and short nights, you get less melatonin. So this is the intrinsic clock-keeping mechanism of all mammalian species and reptiles. Most people don't realize this, but reptiles often have either a thin skull. Birds have a very thin skull so that light can actually pass through the skull to the pineal. Some reptiles actually have pits in the top of their heads that light can pass directly in to the pineal. These are animals that, mind you, also have eyes for perceiving things. But this is the biologically primordial timekeeping device. And you imagine why this would be really important. And then I'll get back to why I think that because humans have a pineal that's embedded deep in the brain, light cannot, despite what some people think out there, I'm not going to name names, but light cannot get through the skull to the pineal, nor is putting a light in your ears going to get there, or even in the roof of your mouth, very unlikely. Maybe some distant stimulation of the neurons in your hypothalamus with long wavelength light. But in any case, the pineal of humans is embedded deep in the skull. And so that information about how much light is in the environment has to be passed through the eyes, through a circuitous circuit through a circuitous path to the pineal. But here's the thing. Here's the conundrum. An animal or human born into an 8-hour day, when days are getting longer, has a very different future as an infant. As an infant or baby that's born into an 8-hour day when days are getting shorter, especially if you live closer to the poles, further from the equator. So think about this. You're a pregnant woman, or you're the husband of that pregnant woman, and you have a baby coming. And you need to know that days are getting longer or shorter and what that means for resources, because the probability of the survival of that child and even the mother during and immediately after childbirth was strongly dictated by what resources were available, the strength of the immune system, et cetera. Yeah. Animals solve this by light going directly into the pineal. I'm not one of those animals, so I don't know if they're conscious of this. Humans needed to solve this some other way. They needed to know whether or not days were getting longer or shorter. And so the question I have is the movement of the stars or planets detectable enough with these telescopes that we have in the front of our skull? Is it perceivable enough that one could know whether or not days were getting longer or shorter simply by looking up at the sky at night? Or are the shifts imperceptible and therefore you would need to create these charts? And now I think it's kind of obvious while I'm asking this question, because to me, this is the reason to chart time. And this is the reason it occurs to me why looking up at the sky at night is meaningful for tracking time.
Absolutely. And not only correlated with that, something even more perhaps basic is, temperature, right? In the hemisphere that you're born in, you would expect that I'm born, as I said, September 9th. Turns out that's the statistically most common birth date of humans on Earth. And why is that? Because
people are busy during the winter holiday.
Exactly, right? So there's a correlation, right?
Yeah, they're at home and they're indoors.
They're at home.
And they're procreating.
And they're right. Or another thing is what month you're born in. Well, you go back 9 months. So actually capitalism's awesome, right? So it's so efficient. So when you go to CVS, I've known this, several times, thank God, because my wife's been pregnant several times, and we have several kids. And when you go to CVS, it's actually pretty interesting. She goes there to buy a pregnancy test. Now she's the kind of neurotic, person that she had to buy like 5 pregnancy tests for each kid. Okay, I don't know why, but that's what she did. So she
likes data.
She's got the gold card.
How do you? Okay, everybody, statistics. Yeah. How do you reduce variability? Increase sample size.
Yes,
right.
Unless it's a systematic error. And that's what I want to talk to you about later when it comes to the eye and other things. You go to CVS, you buy a pregnancy test, and she's on their gold plan program, whatever. She got the gold card from CVS because she's done it so many times. But when you go there, they know you're getting a pregnancy test. So exactly 9 months later, we start getting advertisements for Pampers and for diapers and for diaper creams and wipes and stuff because they know this.
They're hedging even without knowing the results of the test.
What's the downside for them?
Well, if she buys 5 tests, they're probably assuming something very different than if she bought 1 test.
Anyway, so the temperature, right? So if you're gestating during summertime versus wintertime, that obviously will have some kind of an effect. I mean, you can tell me a lot more than that. But more than that, you hinted at this. And I'm not going to make you do any math surrounding pregnancy, but God forbid. But
Hey,
I
man,
sympathize with you.
I put out the correction
I
to
defended
that.
you.
I was talking fast. Well, the irony of that one, I'll just say for the record, I'm just blushing. The irony of that one is that we've published numerous times for my lab cumulative probability, and I teach this stuff. So it's oftentimes when you're going fast, but that one I totally deserved. And I love it. Whatever shades of red I might turn.
That's what a good scientist does.
Oh, man.
But they actually think that the first astronomers were women. Think about it, because they noticed this correlation. What's their monthly cycle? Their menstrual cycle is exactly 29 and a half days, which is actually the lunar cycle down to almost a minute. It's insane, right? That they would have looked up and noticed this renewal and diminishing of the moon. And that there's actually evidence. Now, they weren't professional astronomers until, actually the first professional female astronomer wasn't until like the 1700s in England. Where she was recognized for using telescopes and so forth. But no, they were very keen on that. And they were probably dialed into that and what that portended, as you alluded to, for the future of their child. I mean, this is a huge biological investment. Men don't have that. So actually, we are less symmetrical, this, than women, right? We have our testes or different lengths or whatever. I guess normal men at least. But women are more symmetrical. But they have an extra timekeeping device that men, we can't relate to that.
Their menstrual cycle.
Their menstrual cycle,
yeah. And some women are keenly aware of the ovulation event. They will describe it as a feeling as if it's breaking off and migrating within them. And I have every reason to believe them. Earlier you asked, and I know this will get some people ears pricked up, whether or not when a child is born, with respect to the seasonal cycle, it impacts that child. There are a lot of data around this. Mm-hmm. It depends on the environment in which one lives. So closer to the equator, it's a very different situation.
Right, equal days all day
long. The equal day is all day long. There were some data, and I'd love to get an update on this. So somebody knows, they can put in the comments that that schizophrenia was far more prevalent as you move away from the equator.
Oh, interesting.
And then there was a guy at Caltech, he has since passed, but had some interesting data about mothers who contracted influenza during a certain phase of the second trimester, heightened probability for schizophrenic offspring. But big caveat here, none of it was causal, of course. And then there are all sorts of interesting things about placental effects, and so it's a multivariable thing. Yeah. And we know that because identical twins, even that share the same chorionic sac, one can be schizophrenic and the other no. Although there is a higher concordance than if, say, they're in a dichorionic, two different sacs. So, but time of birth relative to the seasons, seasons correlating, of course, with abundance or lack of food, abundance or lack of various infectious diseases, influenza in particular. These things are relevant.
But we'd have to make a real big stretch to then include the effects of the planet Jupiter, which is the biggest planet and is most of the mass of our solar system outside of the sun. Then it would be clear, and you could do this test with identical twins and that are identical versus fraternal twins that are raised with the same parent. Some are separated at birth and they turn out very much more similarly when they're identical twins. So it shows that genetics play more of a role than we like to think.
Genes are powerful.
They are.
I realize this is a bit politically incorrect to say in certain venues, but genes are extremely powerful.
Yeah, why wouldn't they be, right?
Yeah, absolutely. I mean, nurture matters as well, but
right.
Genes are immensely powerful.
So, and I think that gives us hope. People say, well, we should not be so haughty. We should not be so arrogant. We have 50% of the same chromosomes as a fruit fly. Like, who are you to be? And I say, I'll do you one better. Like, I think some bonobos have 98% similarity, but that should give us more, sort of like treat ourselves and think of ourselves in a way that's more, more elevated, I would say, because we're not that. There's many species of chimpanzees and primates, and so there's only one human, Homo sapien, which a lot of people don't know. The word Homo sapien, which is our species and our genus, sapien doesn't mean knowledge like science. Scientia means knowledge. Sapiens means wisdom, and I like to look at the etymology. I'm fascinated by it. But it kind of highlights what we should be doing and what is it that we are aware of. I mean, I'm curious. Have you ever encountered why are we called humans that like the wise hominid? And it's because we're the only organism that knows it's going to die. Yes, there's some elephants that before the one dies, the one will take care. It's not the same as you knew you were going to die when you were a kid, very young, and it's that awareness of death and the awareness of how special we are. I think that's what invests life with a lot more meaning. I don't want to get too philosophical.
Yeah, it's time perception.
That's exactly what I was going to say.
I'm an expert on happiness sitting here, and then Morgan Housel is an expert on the relationship between psychological happiness and money sitting here. And he described this cartoon, which inevitably makes me chuckle, of a guy and his dog sitting by a lake, and there's a bubble, sort of bubbles coming out of the guy's head, and he's thinking about whatever his stock portfolio and things back home, et cetera. And out of the dog's head is just a mirror image of him sitting with his owner. The dogs are very present, but what that also means is that they are not able to perceive their own existence within and
modeling
time.
of time, as you said before. We can forecast. That's how we don't have the strongest muscles, the sharpest claws, the biggest teeth, right? What do we have? We have this prefrontal cortex that allows us to do what are called Gedanken or thought experiments, Einstein said. To predict the future, to model the future, not really predict it, we can't do that, but we can model likely outcomes and we can simulate in our minds what those would be like. And we're so dependent on that skill that we sometimes confuse, correlation for causation. And as you know, everyone who confuses correlation with causation ends up dying. So it's very dangerous to do that. But the point is, the notion of what's called confirmation bias is prevalent in every human being, scientist or not. And in fact, as scientists, you and I, we have to guard against that more than anybody, because nothing really feels better than thinking of a hypothesis, modeling the future, and then feeling like you're right. And then you get celebrated and feted. Maybe you win a golden medallion with Alfred Nobel's image on it or whatever. Those kinds of things are very powerful. And those kinds of things are also very dangerous, which is why it appeals to so many more people to think that the celestial orbs play a role in our lives. It's almost like we've reverted to a paganistic existence where we want to believe there's some force responsible for our fates when maybe it's random.
I totally agree with you. I'll play devil's advocate for a moment, not for astrology per se, but for instance, there are many species that use magnetoreception. They can sense magnetic fields.
Sure.
I think turtles do this, some migrating birds do this, some pigeons.
Yep.
There's even some evidence that within the, I believe this is still true, that within the eye of the fly, the fruit fly, that there are some magnetoreceptors.
Yeah.
So turns out there are some humans that perform better than chance in a magnetoreception perceptual task.
Yeah.
This is very surprising to me. It can be trained up somewhat, but I'm sure there are a number of people hearing this that they themselves feel that they can sense magnetic fields. There is a capacity to do that greater than chance in some individuals. It's a very weak capacity.
It's very small,
So I think humans love the idea that there is something, skills or qualities beyond our reflexive understanding that we all harbor. This idea that we have superpowers that we just need to tap into.
Sixth sense, right.
Sixth sense, or this person has a stroke and suddenly is speaking conversational French, and therefore, neuroplasticity, et cetera.
Or what's a proprioception, or our colleague when you were at San Diego, Ramachandran.
Oh, Ramachandran.
Yeah, the synesthesia. right?
Certainly synesthesia exists.
Yeah.
People who will hear a certain key on the piano and immediately evokes the perception of a particular color, not just red, but a particular shade of red in a very consistent way.
Now, if that was useful for something, maybe it is useful. I mean, it might be
unusual cross-modal plasticity is what we would call it. Yeah.
But so could that not be made into an argument? Well, that means that this is a general feature that we just don't know how to access. But maybe like we could go to the gym and mental gym or do something to enhance that, like you said. I don't know. Some people do that with like infrared, near infrared wavelengths that they do some kind of training and they claim they can see certain things. The question is, how useful is it? And then how predictive is it? And I don't think that we can make a case for the predictive elements of the position, as I said, of Mars and Mercury being in retrograde as it is now. Like most people, but the thing that's shocking is that, like, look, there's a whole page in almost every newspaper except the execrable New York Times. No, I'm just kidding. The New York Times
Are they still around?
They don't. It's very interesting. I'll tell you off the air a recent encounter I've had with the New York Times. But most newspapers have more, hundreds of times more ink written about astrology than astronomy. I mean, it'll barely be in there. And why is that? It's capitalistic society. So people crave this notion that there's some explanation for the random seeming events that occur in their lives, and that's an urge as ancient as human civilization itself.
I'd like to take a quick break and acknowledge our sponsor, AG1. AG1 is a vitamin mineral probiotic drink that also includes prebiotics and adaptogens. AG1 is designed to cover all of your foundational nutritional needs, and it tastes great. Now, I've been drinking AG1 since 2012, and I started doing that at a time when my budget for supplements was really limited. In fact, I only had enough money back then to purchase one supplement, and I'm so glad that I made that supplement AG1. The reason for that is even though I strive to eat most of my foods from whole foods and minimally processed foods, it's very difficult for me to get enough fruits, vegetables, vitamins and minerals, micronutrients, and adaptogens from food alone. And I need to do that in order to ensure that I have enough energy throughout the day, I sleep well at night, and keep my immune system strong. But when I take AG1 daily, I find that all aspects of my health, my physical health, my mental health, and my performance, both cognitive and physical, are better. I know that because I've had lapses when I didn't take AG1, and I certainly felt the difference. I also notice, and this makes perfect sense given the relationship between the gut microbiome and the brain, that when I regularly take AG1, which for me means a serving in the morning or mid-morning and again later in the afternoon or evening, that I have more mental clarity and more mental energy. If you'd like to try AG1, you can go to drinkag1.com/Huberman to claim a special offer. For this month only, January 2025, AG1 is giving away 10 free travel packs and a year's supply of vitamin D3 K2. Again, go to drinkag1.com/Huberman to claim the 10 free travel packs and a year's supply of vitamin D3 K2. It speaks to what I think is one of the core functions of the human brain, which, umbrellas everything we're talking about, which is the human brain is a prediction-making machine. And it wants to make predictions on the basis of things that feel reliable. And the ability for us to, confirmation bias, the ability for us to link A and T as opposed to A, B, C and work through things linearly and try and disprove our own hypotheses is much stronger than any desire to work through things systematically unless you're trained as a scientist.
Exactly, yep.
And so it's no surprise to me that people want to understand themselves and understand others in a way that feels at least semi-reliable, and to do that in a way where they don't have to run a ton of experiments, and hence astrology. I'd like to stay within this vein of thought, but you said something earlier that's been kind of, nagging in the back of my brain. You said we have two refracting telescopes in the front of our skull. I will often remind people that your retinas that line the back of your eyes like a pie crust are part of your brain, your central nervous system that was literally squeezed out of your skull during the first trimester through a whole genetic program that's very beautiful. And this might freak you out, but think about it. This is the only portion of your brain that resides outside the cranial vault. Yeah. Technically still in your skull, but outside the cranial vault. Gives humans an enormous capacity that they wouldn't have otherwise, because what you can make judgments about space and time, space based on what's next to what's far from what, and time based on movement of things relative to stationary objects, et cetera, that we wouldn't otherwise be able to perform, right? You could sense odors at a distance, smoke, et cetera, but it's a whole other business to have these two telescopes. Could you explain what you mean by two refracting telescopes? Because I think that will set the stage nicely for some of our other discussion about optics.
Yeah, so I've been in love with telescopes since the age of about 12 when I could first afford one to buy one of my own. And that really came out of the fact that I recognized the limitations of the human eye. It turned out I was 12 years old, woke up in the middle of the night one night. There was this incredibly bright light, brighter than these lights here, shining into my room. And I was like, I don't know, there's a street light outside. This is crazy. Let me look outside and see what it is. And it was the moon. And I had never seen it. It was near a Moonset, which is near sunrise, full moon. And I looked at it and I kept staring at it. And there was a star next to it that kind of looked like a piece of the moon had broken off. It was that bright and that clear. And it's unusual to see these kinds of things together. They're actually known as syzygies, which is a great Scrabble word. If you're ever pressed for a win in Scrabble, use the word syzygy. I think it's like 80 points. And that just means a conjunction, an alignment of astronomical objects. I was like, what the hell is this? This is 1984, Andrew. You're younger than me, but Google did not exist for another 16 years. And I was kind of impatient. I wanted to know what this thing was. What is this thing? It's not moving. It's not flashing. It's not a drone. Back then, it's not Southwest Airlines, right? So I'm looking at it. It's not moving. And day after day, it was like that. And I was like, how am I going to find this out? Like, imagine we're so blessed that we have the internet and we have these LLMs. It's so easy now to be a scientist or do research, and anybody can do research. Science is for everybody, right? You always highlight that fact. So I realized the only way to find out about it was to wait for the New York Times to get delivered on Sunday, because they did have a section back then that they don't have now called Cosmos. And in it, it depicted what the night sky looked like that night, which is a Sunday. And that was like 3 or 4 days after I had this observation, which, I was incredibly, observant. And I looked at it and it was the moon. It showed the moon and it showed Jupiter. I was like, what? You can see a planet with your naked eye? This was around the time Voyager, was going by the planets on the grand tour of the solar system. Never been done before. I was like, I thought you needed a spaceship, and I realized that was my first bit of astronomical research. I looked up, I had a hypothesis. What is it? I was wrong. I thought it was a star. It was a planet. I was like, this is insane. Imagine what I could see if I had a telescope. But I couldn't afford a telescope. We were pretty modest means back then. I had a job working at a delicatessen down the street, and I do that once a week. And then, I got a grant from a 3-letter agency, which is the beginning of many, many scientists' careers. I got a grant from the MOM agency, my mother. She supplemented my $2 an hour salary at the Venice Delicatessen in Dobbs Ferry. And I ended up getting a telescope for $75. And I, cherished this thing. And then I was like, let me look at these things in the sky. And it's pretty amazing. I don't know if you know the history of telescopes, but the first ones were invented because of the glass that was present to make eyeglasses. So telescopes came from eyeglasses. Where was the best glasses? Where were the best glasses made? In the Netherlands. So actually the telescope and the microscope were both invented in Holland. And the guy who invented the telescope is very interesting, because it would be like he made the telescope, but he never thought to look at the night sky with it. He only used it as a spyglass to look at objects, on the horizon or in a city or whatever. He never went like this, looked up, in 45. That required Galileo. So he was my absolute hero of all of science. We'll talk about him later, maybe. Galileo was the first person to ever look up with this telescope and spot objects in the solar system, in the universe, that had never been seen before with a scientific tool. So everybody had used their eyes, back to Tycho Brahe, Kepler, Copernicus. They had to use their eyes, which are telescopes. I'll get back to that. Don't worry. I know you afford me the podcaster's, predilection of going off on long tangents, but I think this is good. Yeah. Galileo then said, well, I'm going to take this telescope and look at these objects that are otherwise look like stars. And in fact, were called, basically wanderers, because they're the only things that moved. He first looked at the moon. Now take yourself back to 1609, when he was first looking at these objects. 1609, there were no clocks. There were no scientific tools of any real virtue. He, in fact, would invent many of these things. There were simple things like a magnetic compass, a slide rule, which no one in your main demographic will know what a slide rule is, but that's okay. Very simple tools. They would use tubes and whatnot. But Galileo looked at the moon, and the hypothesis was everything in the universe is orbiting around the Earth. The Earth is the most perfect place in the universe because God puts the things that are most important close to him in the center of the universe. God is the center of the universe. The Catholic Church held this. And everything will go around the Earth. And in fact, I'm not going to challenge you because I think you'll defeat me in this. But in your audience, there are probably very many educated, I call them .edu people. There's many, many educated people. I find that even with my brilliant students at UCSD, they can't prove that the Earth is not the center of the solar system. In other words, I'll say on my Astronomy 101 quiz, I'll say, prove that the Earth is not the center of the solar system, which was the whole universe back then, right? And I would say it's about 75, 80% will not get it right. In fact, I can say to most people, prove the Earth is not flat. I claim the Earth is flat. Prove me wrong. Most people can't prove it. They don't know how the proof is constructed. I don't expect them to go and replicate what Aristarchus did, 2,000 years ago. But this is knowledge we've had for, as I said, 2,000 years. The knowledge that the Earth goes around the sun and not the other way around is only about 400 years old. But I would say 99%, I know for a fact. I went to Italy actually 10 years ago. It was the 100th anniversary of Einstein's theory of general relativity. And we had a ceremony to honor the first person who ever came up with a theory of relativity, which is also Galileo. Galileo had the first notion that relative motion is indistinguishable. That if you and I are on a bike and I'm stationary, you can't tell if you're moving, I can't tell if I'm stationary. That's called relativity of motion. Motion is not absolute. Einstein would later enhance that, put on steroids and then come up with all sorts of cool stuff that we can get into. But this notion that you could do observations, that you could use a scientific tool, couple with a hypothesis, and then iterate on those hypotheses to make both the instrument better and your hypothesis better, and then expose that to scientific peer review, which was not what we have today. That was done by Galileo. He was the first person to use the scientific method. What did he use it with? A telescope. So a telescope that he used was a refracting telescope. Lenses like eyeglasses, two of them, one put at the far end called the objective. It's closer to the object. The other one, the eyepiece, close to your eye. And he was able to magnify things about 3 to 10 times pretty easily.
Can you explain refraction for people that
Yeah.
are not
So when
familiar with it?
light travels at the fastest speed of any entity, photons travel at roughly 300,000 kilometers per second, except when they go into a medium. That's what they travel in the vacuum of space or in a vacuum in my laboratory or whatever. But when they go into a medium that's transparent or translucent, they slow down. You can think of it as the light waves themselves. Imagine light waves as rows of soldiers marching together. And then imagine that they're walking at an angle to the beach here in Los Angeles. They're marching at an angle. The ones that encounter the water first, they start to slow down. The other ones keep moving at a fast speed. And then the whole beam of light, the whole beam of soldiers gets bent. That process is called refraction. We can do it. Well, this yerba mate is so delicious. We can't do it because it's got a little bit of cloud to it.
Similar to, for instance, if you go and look at a fountain and you see a coin and you decide, you're going to be that mischievous kid and you're going to grab that coin. So you can throw it back in like any you can recycle the wish. And you reach down to grab it and you miss because where you see it is not where it actually is.
Yeah, put a pencil in a clear glass of water, same phenomenon will happen. That's refraction. It's the bending of light by what's called a dielectric or just a medium that's transparent or translucent. And you can do that in a way that you shape the wave of light coming in that it will be magnified. And that's in fact what a telescope does. Tele means distance, scope means viewer. So a telescope really means distance viewer. A microscope means small thing viewer. And so this was kind of revolutionary to use it for scientific purposes. Galileo did other things. We just take these for granted. We got all these cool cameras here. These are all refracting telescopes. You can see the lens in one. You can see that it's on a tripod. Galileo invented the tripod. We take these things for granted, but people didn't realize that.
What a stud.
Yeah.
I want to get a list of all the things that the Galileo did. I'm going to pause you for 1 second, and please earmark where you're at because I have a number of questions that I just can't resist asking.
That's fine.
First of all, if it's too lengthy an answer, feel free to say, pass. But why was the best glass in Holland? What is it about the Dutch and good glass?
I think that they were extremely, as they are now. I have great colleagues that are from the Netherlands. They were obsessed with high quality, as Germans are. They're very similar to Germans. Very into very precise instrumentation and high quality. It's interesting to note that that glasses were only really invented in some sense because of the fact that there was an existing standard for human visual acuity. Okay, so we all know we go to the eye doctor.
You mean eyeglasses?
Eyeglasses, yeah.
Right.
So we know today that when you go to the eye doctor, there's an eye chart, right?
Yeah,
and we all know
it's called the Snellen chart.
Snellen chart. Okay.
Yeah, when you go to the DMV, you use the same thing.
Right.
It's numbers and letters of different sizes that at a given distance, if you can read all of them, then you have whatever high acuity. Let's just say high acuity vision. We won't get into. We won't get into. And if you can only read 3 lines down, and then you're essentially blind to the rest, then you have less than average vision. And in the state of California, they'll still give you a driver's license.
Yeah, that's right.
There are many people, by
Pilots
the way,
too.
there are many people driving in the United States, by the way, who qualify as legally blind.
Holy crap.
But because when you drive, you mainly use your peripheral vision, they are granted a driver's license. This should terrify everybody.
But all those eye charts, every DMV here has the exact same size for the E at the top, okay? It's a calibration standard. How could they do that 400 years ago? We're talking 430 years ago. It turns out there was one and only one standard that was acceptable across all of Western Europe. It was the Gutenberg Bible. The Gutenberg Bible was set in print by Gutenberg, and it had a fixed size of all the characters. So what they would do is at a couple of feet, they put the Gutenberg Bible in front of people. It's amazing to think about it because there's only like 10 copies of the Gutenberg Bible still left. They're all in vaults. They're all worth hundreds of millions of dollars. You can't buy them even if you're, Elon. When you look at it, you would be able to tell that you could not see at 1 foot what I could not see what Andrew could see at 1 foot. So you knew that there was something diminishing my visual acuity, who knows what it was. But they knew that they could then correct that lens to be as good as 20/20 or get up to your standard for me. And that was the way that they would judge how good your eyes were. And so they then would correct that with lenses. And I always point out how ironic it is because later on Galileo would take those 2 lenses and instead of putting one on each eye, he'd put one in front of the other one and then use that to construct a telescope. But he didn't actually invent the telescope, but he perfected the telescope. So just like Apple didn't invent the smartphone, they perfected it. Just like Facebook didn't invent social networking, they perfected it, right? So it's usually the second mouse gets the cheese, they like to say. He was the ultimate second mouse. He would always improve things and make them so much better that he would obliterate his competition. Galileo.
But it was Copernicus, if I'm not mistaken, that was the first to say that the Earth revolves around the sun while rotating on its axis.
That's right, yep.
And tilts, which gives us the equinox.
Correct, yes.
Okay, so Galileo corrected Copernicus about the math, but it was Copernicus that gave us the first trusted statement that the Earth and the other planets rotate around the sun?
Yeah, I would say he gave the hypothesis. He wasn't wrong. Galileo didn't correct him. It just Galileo brought evidence to the table. He brought hard scientific observations.
So who's this Copernicus guy? Was he just sort of like a iconoclast? He's like, hey, how about we're not the center of the universe, it's the sun that's the center of the universe?
Well, so what was the milieu of the time was that the Earth was the center of the universe, which was our solar system effectively was the whole universe. They didn't know about stars and galaxies, certainly. We can get into that later. But there was what's known as the Ptolemaic concept of the organization of the cosmos. So the earliest cosmological models were that the sun is the center, the Earth is the center of the universe, and everything goes around it. However, these were not dopes. They knew that there were problems with that model. There are certain aspects of the orbits of planets. For example, I mentioned Mercury's retrograde, and what does retrograde mean? We don't have to get into it, but there are anomalies that the planets will undergo at different times of the year. Due to the fact that the Earth is, we know now, rotating, revolving around the sun and rotating on its axis, but the main effect is its revolution around the sun. And the other planets are too, in the same plane, the zodiac plane, what's called the ecliptic, due to the angular momentum of the proto-solar system. And sometimes the Earth goes faster than, say, Jupiter. So originally it'll be out in front, if you will, of the planet, forward center of motion, as you like to say, and then it'll be behind it later on. And so it looks like the Jupiter is making like this weird S-curve. And they couldn't explain that if the Earth is the center of the solar system, except that they added on what are called epicycles. They added on extra little orbits of the planets in order to account for that motion that sometimes it appears, yes, we're moving bulk motion, but then sometimes it goes in the opposite direction when we're going in the same direction.
So smart.
Yeah, they were
and they must have known by modeling this stuff on Earth, between objects on Earth.
100%.
And that raises, for me anyway, an important psychological question. So you've got these Dutch folks with great glass.
Yeah.
They're using that great glass to correct vision.
I should say, sorry, Andrew. The reason that they had good glass is they were some of the foremost explorers, right? A lot of the early trade, and they were, what did exploration give them? Access to trade. So they could get the finest silicon and glass, and they could make it themselves. That's their economics. Again, capitalism always wins, right? This is a lesson that we shouldn't forget. Their commerce, their economies allowed them to do trade and acquire the best, highest quality materials. Then that was used to make the best scientific equipment. And it's just curious. It'd be like, if they built these scientific tools, but they didn't use them for science. So imagine like building the Large Hadron Collider or SLAC or something like that. And then just not using it, just like using it to like measure.
Well, I think SLAC is sitting empty, right?
Basically, but it wasn't originally. That's the point.
Right. It was used for something. So, what I'm curious about is, why do you think it is that some humans get some technology, in this case, glass, and they want to look at things that are very close up?
Yeah.
I like microscopes a lot.
Yeah. No,
I right now, I don't have my wet lab. We're still involved in some clinical trials, but I love microscopes. That's and awesome. I loved customizing my microscopes. Yeah. I didn't like them. I don't like a plug and play. I like them sort of the same way that people like hot rods. I didn't like motorized stages. I like manual stages, this kind of thing. Nowadays, you need motorized stages, et cetera. But what was I going to invest my money into? It was higher numerical aperture.
Yes.
Better. Basically, you're able to see things better.
Deeper
view. Yep. Right. Exactly. See smaller things better. That's what numerical aperture will do for you. So It's like putting more horsepower into a car, as opposed to paying more attention to the paint job.
People do that with their cameras. They geek out.
Right.
On
Everyone's
lenses,
got their thing.
Yep.
Humans have this glass, and they have the option to look at smaller and smaller things or to resolve their vision. Why do you think it is that a subset of humans, because I think it's a special subset of humans, instead, I want to look at things really far away.
Yeah.
And you're one of these humans.
Yeah.
I mean, I delight in the stars. I delight in the moon. I have some questions about that I think most people have who appreciate sunsets and moonsets and things like that. Mm-hmm. But why do you think it is that it tends to be a small subset of people who don't just want to appreciate the night sky, but want to figure this stuff out that is so far away? I'll be honest, it never occurred to me. Mm-hmm. I'm curious about things deep under the ocean.
Yeah.
I am very interested.
Fish.
I'm very interested in fish and aquatic life, but I like terrestrial things, arboreal things in trees, and I think most people orient to the stuff that's more of this planet.
Yeah.
What do you think it is? I realize you're not a psychologist, and there's probably no DSM whatever 6 diagnosis specific for this.
Check them all off. Yeah.
But I'll just ask you, for you, was it a desire to better understand life here on Earth, or was it a desire to kind of leave life here on Earth?
I think it's the latter. I mean, my childhood was, pretty tumultuous. I think you and I have a lot of things in common. Both fathers, scientists, and physics and math in my case. Very hard driving, very hard to live up to their shadows that they cast, for example. At least in my case. And you seem to have just a beautiful relationship with your dad now, but I'm sure it wasn't always like that. In fact, you talked about that.
We did a lot of repair work, and I'm very grateful for where we're at. And I encourage anyone, son, daughter, mother, father, whatever relationship, that the repair work, to the extent that it's possible, is absolutely worth it.
Yeah, and that episode I texted you is a real gift, not only for all of us who got to witness it, but also, for grandchildren, him, his legacy and so forth. And even, his mom, your dad's wife and your mom. But the point is, yes, it transported me. I was living through, after the divorce of my parents, I lived with my stepfather, who had adopted us, changed our names, moved to different, we were changing, schools every couple of years. And that discovery of the, moon next to Jupiter, it was sort of like solving a puzzle. And there's a famous saying by, Albert Michelson, who was the first Nobel Prize winner in American history.
For what?
Physics, sorry.
For physics,
Michelson Morley, he proved in some sense that the Earth is not moving through the ether, that was hypothesized by luminaries beforehand. But the point was, when a child solves a puzzle, like, you would think, well, like an adult, you solve a Rubik's Cube. Okay, I did it once. I don't have to do it again. But like my son, he'll keep doing it. He'll keep showing off. Can I get it faster? Video games, same thing. Once you solve you don't just throw it out and stop doing it. You get a taste of that thrill of discovery. Yes, it's diminished. And yes, we become inured to it as we get older and a little bit more, there's just things we have to get, take care of in life. And especially as a professor scientist, you can't like marvel over the same things you did when you first did these experiments. But as an experiment, you get transported and you get to, encounter something that you feel like no one has ever done before. For example, when I got my first telescope that night, a couple of months after discovering this, I looked through it and I saw the same features on the moon. And I have a 3D printed moon that my son made, to show you. And it has all the craters represented on it. So cool. And I saw the exact same craters on the moon that Galileo saw. And then I looked at Jupiter. And when you look at Jupiter, you not only see these beautiful atmospheric bands on it, and I brought you a telescope as your end of the year holiday gift. It's yours to keep, and no money down.
Thank you.
And Keating brand.
Thanks
telescope.
for the gift.
Yeah. And I looked at Jupiter. And when you look at Jupiter, as I hope you'll do tonight or with your crew later on, you will see not only the planet, not only its little atmospheric stripes, maybe even the Great Red Spot, which is amazing, 3 times bigger than the Earth. You can see it from Earth with this little telescope I got you. But you see 4 little stars. And they're 4 stars that are to the left, to the right. They're in a plane with the midpoint of these equatorial storms that are brewing on Jupiter we know that they've been going on for at least 400 years because Galileo saw them. So that sets a limit, minimum.
Storms,
time.
When you say storms, what do these storms
Hurricanes.
consist of?
They're enormous hurricanes on the planet. And the equatorial bands like the Tropic of Cancer and the Tropic of Capricorn.
So there's plenty of water up there that's raining down?
No, it's not water at all. It's methane, ammonia, but it's a fluid. So it behaves like a fluid doesn't. So you have these swirling whirls, and the colors will amaze you. You'll see colors on an astronomical object. It's going to blow your mind. And not only is it going to blow your mind because you're going to feel unique in all of science. You will feel what Galileo felt. You won't know that he felt it before you. A billion people have seen it since then. Because for you, it's new. And for you, you're viscerally connected to the maestro, to Galileo, and what he did. And there's no other branch of science that's like that. You can't look at the Higgs boson. First of all, no one person did it. It's a team of 3,700 people that discovered the Higgs boson, and 7 people predicted the Higgs boson. Higgs is just one of them. One of my professors at Brown was another one, Jared Graunik. He passed away, unfortunately, never won the Nobel Prize. But the point is, you can't know what that felt like. You can't know what it felt like to discover gravitational waves because thousands of people did it recently in 2015. But the question of visceral connection to the first discoverer of that phenomena, it's unique to astronomy. I don't know of another branch of science where you can have that. And best of all, from here in the center of LA, you can see the same craters. You can see these 4 Galilean, they're called the Galilean moons of Jupiter. And we're sending spacecraft there now to see if they have life on it. It's incredible, Andrew. There's nothing else like that in all of science. For $50 to $60, I have a list on my website, briankeating.com. I have a telescope buyer's guide that I send to people. I don't make any money from it. It's just I love to share science with the public, just like you. But in my case, it's astronomy. And for $50 or $75, you can have this experience that Galileo had. It's an awesome feeling. And I think that's what kept me going. It distracted me from the pains of, the life that I had at that time and, just struggling as most preteens and teenagers did. But to answer your question that you asked 20 minutes ago, it was really to teleport, exactly the opposite of the telescope. I really felt like I was transported to these other worlds. And I could understand them with simple math and simple tools. Night after night, they were reliable companions and that people love to see it. You'll see Saturn, hopefully, with it. You can't help but feel this is, amazing. It's thrilling. And it allows you to do science with your eyes connected to your mind. It's incredible.
So it sounds to me like you were, thank you for sharing that, by the way. It sounds like you were able to connect to places distant in space, obviously, and time, Galileo. Mm-hmm. That's beautiful. I don't think the same experience occurs when one looks down the microscope. I mean, it's true that the greatest neurobiologist of all time by a long shot was Ramon Cajal, right? Kind of supernatural levels of ability to understand what turned out to be the correct function of the nervous system just from anatomical specimens. But when I look down the microscope and I see even a Cajal-Retzius cell, there's a cell named after him, you don't really feel a connection to him in the same way, although the neurons are beautiful, but it's not the same the way you describe.
What's great about science in general is that the best science is apolitical. But I always say, look, there's no such thing as like, oh, well, that constellation is a democratic constellation. Oh, you see that asteroid? That's a republic. No, it is a safe space. So I think we do need safe spaces. And at best, science is a safe space, not meaning It never interacts with politics, because of course it does. But for those moments, we as humans, and you know this better than I do, we need recovery. You can't just work out. You don't work out 7 days a week. You work out 6 days a week or whatever. It's still more than I work out. But the point is, we need to recover as much as we need to pay attention to the activity. We need to recover, pay attention to that too. And so the question is, where can we recover from social media, from politics, from economic stress and all? I think science is an ideal vehicle for it. It should be apolitical. We shouldn't be, always concerned with, politics or what's happening on social media. And I'm guilty of this too. I'm certainly spending way too much time on screens. But the point being, science can be that. And astronomy in particular, like I said, it's apolitical. It is safe to let your mind run to what you used to do when you were on a dorm with your bros at, 3 a.m. just BSing, right? We don't get a chance to do that when you're thinking about mortgage payments and like who's taking the kids tomorrow and all these different, quotidian things, as I say. We need to get back to that more than ever, I feel.
Pondering the origins of life and connecting to people who existed thousands of years before us.
That's right.
Do you think that Galileo, Copernicus, and others were doing the exact same thing? That there was a bit of an escapism to it, healthy escapism, as opposed to trying to solve the position of the planets and understand ourselves for some other reason?
Definitely, yeah. I mean, Galileo in particular is sort of this tragic figure in some ways. He had the first notions and application of the scientific method, as I said, using an apparatus to confirm a hypothesis, iterating on that. So I said when he saw the moon, he saw these craters and valleys and rifts and lava fields that you'll see tonight. Again, people, you can buy a telescope on Amazon, $50, and you'll see these same things that he saw. And you can connect it to your iPhone and post it on Instagram if you want. And I hope you'll do that. That's your only homework assignment. The only one I'm going to assign to you as a professor.
Assignment.
So I want you to take a picture of the craters on the moon. But the point is, you'll see the exact same things. From New York City, you can see them. From the middle of London, it doesn't matter where you are. If you have a clear sky and the moon is out, you'll see the same thing. But when you look at Jupiter, you'll see these 4 dots. And here's where Galileo just had this otherworldly intellect that, when I saw those, I was like, oh, cool, it's next to some stars. Until I realized that I had to do more research, that those are actually the moons of Jupiter. So in one night, tonight, you can, quadruple the number of moons you've ever seen in your life. And some of those moons are almost the size of our moon. Our moon is unusually large. And those moons, sometimes they'll cast shadows on the planet. So there'll be an eclipse. You'll witness an eclipse on Jupiter, on another planet, with this $50 instrument or whatever, okay? When he was observing these things, he would do things that were not only psychological, and they were therapeutic for him in his later years. I'll explain that in a minute. He ended up going blind, and so losing the sight, and kind of the recollections that he had. And he lost his daughter, who was a nun, because she was illegitimate, as most of, I think, all of his kids, except maybe one, his oldest one. He had mistresses. He was married, divorced, basically, and I was kind of like, he was Catholic in Italy, primordial Italy, basically. It didn't exist as a country, but he was in Tuscany. And he had a lot of challenges. He was almost always broke. Even when he invented his version of the telescope, again, he didn't invent the telescope, but he made it so much better, 10x'd it, 20x'd it, 0 to 1. And it was incredible what he did with it. He realized, this is great and all for me to discover these cool things and learn about the universe. He was deeply religious too. But I got to make money. I got to pay for my house. He had imagine your students at Stanford are living with you because that's the only way you can afford to pay rent in your house. I mean, and you're cooking meals for them. And they're like slobs, right? I mean, I was a slob in college, right? So the point is he had bills to pay and he was a businessman. He realized, well, look, if I start making these telescopes, everybody will see the things that I'm seeing. I won't have any monopolistic advantage over, Kepler, who is his friend, but also his competitor. They were really vying for who is the best astronomer of all time. Kepler in Germany and obviously Galileo in Italy. Well, become Italy. And he realized Kepler was purely theoretical. He had great math chops. He came up with functions for the orbits of planets before Isaac Newton proved that they came from calculus and universal gravitation. Incredible scientist. But if he gave that, and it was like giving a free particle accelerator to your arch competitors, right? He didn't do that. He said, no, I'm not going to make these telescopes, but I'm gonna sell them only to the government, and they're going to pay me because these are great military devices. And we don't think of them now, but with it, he's so brilliant. He was so charming and charismatic. He said, I'm not only going to like sell you these things. First, he went to the Senate in Venice, the Venetian Senate, the Doge, the original Doge. We think Doge is a coin or some department that Elon's going to head. No, it was the Doge was like the chief of the government back in the Venetians, which is one of the most wealthy countries in all of Europe. It was separate from Tuscany and separate from Rome. And he went there and he said, you are a maritime, have you ever been to Venice? Mm-hmm. Yeah, it's beautiful, right? So he said, look, come with me. I'm going to take you up into the Piazza San Marco, go up to the tower, and we're going to look out and we're going to see there's a ship out there, but you can't see it with your naked eye. But if I give you the telescope, you can see it 3 days earlier before it comes into your harbor. That's like you have an F-35, stealth fighter, and you sell the rights to turn off the stealth portion of it to your adversary. And it's incredibly valuable.
It's a time portal.
Yes.
You could tell I'm keep harping on this theme of, the ability to see things at greater distance.
That's right.
At higher and higher resolution gives you a window into time.
Exactly. And we speak of that now.
That has enormous advantage.
Exactly.
There because of the trajectory of the ship.
Yeah.
You actually are getting a sort of crystal ball into what's going to happen
Predicting
later.
the future, as
Whereas
you said,
looking at position of the stars, some anticipation of what's going to happen based on historical charts of the stars.
So we even speak of that now, and then come to think of it as you're saying it, light years. What is a light year? It's a measurement of distance, but it's in terms of time. So it's exactly consonant with what you're saying. We are always going to have this combination, this interrelation, this competition between things in space and things in time. And he realized with this tube that he could see to great distances, that also afforded him this extra advantage when it came to predicting the future, as you say.
If we could do a top contour survey of the greats of astronomy, where would it start? Starting with people who got it wrong, and then correct each other. Like if we were going to do a fast sprint through these, where would we start?
Well, you'd have to start with Gog or whatever, the first cavemen and women. As I said, 40,000
charting stars on the wall.
Exactly. We don't know who they are.
Telling their youngsters okay, because those stars are there relative to that ridge or et cetera, days are getting longer, days are getting shorter.
That's right.
Ergo, hunt now. Ergo, collect stuff to
Harvest.
Hunker down. Maybe even don't reproduce now. Maybe even behavioral restraint.
100%.
Maybe reproduce now.
Yeah.
Yeah.
It's going to be much more, optimal time for that. Right. Exactly. So tens of thousands pre-antiquity, you would say. Then I would say fast forward, to the maybe Egyptian epoch, 5000 BCE, so to speak, when they had also a very zodiological and astrological conception of these objects. But and yet they would build things, in relation to the positions of stars and constellations.
Sundial emerges.
Sundial, obelisks, things that were used, primitive things. Stonehenge also, I think it's like 20,000 years ago. They believe it's related to some astronomical observations. They're not entirely certain about that.
We have to double click on Stonehenge. How do you think it got there?
It's one of those great mysteries. I think it's less controversial, Stonehenge, than the pyramids. The pyramids seem to be like almost, they lead people into thinking about aliens and all sorts of stuff.
But what do you think of? Is it? I mean, given their mass, given their location, given what we knew about populations then, and given what we know about the strength of people and the tools they had at the time, is it reasonable to assume that people built these things?
I mean, certainly. I mean, you'd have to convince me that people didn't build them, but exactly how they built it is a great question. I mean, so for example, I mentioned this when I was on Joe Rogan's show. I said, if you measure the bases of the pyramids, it turns out that they're a ratio of a cubit, which is actually cubits, not quantum bits, like you and your dad talked about, but cubits is the length of the pharaoh's forearm. It's basically 1.5 feet roughly. So back then, if you were like the president, you were also the metric standard for all of civilization.
Wild.
And it makes
sort of like models on Instagram, right? Everyone's trying to attain these. What's the standard?
That's right. Exactly.
What's the standard?
Right. That's right.
Wild. So the pharaoh's
Instagram
forearm
famous.
is this about carrying items?
Well, it was just for length or like a foot. We talk about a foot. It was a pharaoh's foot.
Sure.
Yeah, that's where we get those from, right? So there was only kind of one rough standard for calibration, which is incredibly important for removing systematic effects in science in general. So you had a calibration standard. Now we have like a bar of platinum. We've defined, the second in terms of oscillations of a certain atom called cesium and how many times it oscillates per second.
Sure, a degree, right? Yeah,
Yeah,
a calorie, right?
So now we want to define those in terms of physical quantities, not in terms of people. And so doing that has been a great advance forward in science. And we've only recently gotten rid of what are called artifacts. So it used to be there was a rod that was 1 meter long. And the meter was originally defined as 69,000, I forget, of the distance from the North Pole to Paris. But that obviously depends on assuming the Earth is a perfect sphere, which it's not, right?
It's kind of chubby around the middle,
yeah,
right?
That's right. It bulges because it's an oblate spheroid, right? Exactly. And so all these things that were relics, we want to get rid of them and tie them to fundamental properties of, say, a quantum system that's very pure and we can isolate it. We don't want to use a pharaoh's foot either, so we have to come with a link standard. So now we use the speed of light times the second, and we can define things in those terms. But back then, so they didn't know that. But I told Joe, as I said, if you measure the base of all the great pyramids at Giza, they're all multiples of a cubit times so many numbers of the number pi. So but pi wasn't known to them. Pi wasn't known to be irrational until the Greeks and Euclid proved that it was irrational, and that it didn't come from a computational. It couldn't easily be obtained from. It had an infinite number of digits, right? So how did these Egyptians know that? An alien told them no. The way they did it is they laid it out. They used a surveyor's tool. One of the surveyor's tool is a stick with a wheel on it. So the wheel's a circle, so you got so many multiples, they just counted, and that's how. So we confuse a lot of things.
They stumbled into pi.
Exactly, right? They walked all over. So you don't have to always posit supernatural explanations for things. The answer is simply, we don't know. I certainly don't know how Stonehenge was built, nor do I know how the pyramids were built. But it's not. You would have to convince me that it was built by some other means other than people and the tools that were available to them.
Yeah,
and there's a lot of
likewise. I'm not convinced it came from extraterrestrial.
Yeah, so I don't remember how we got on this, but
so we were marching through.
Yeah.
So we were marching through.
Right. Yeah.
So we have our ancient ancestors, and then at what point do we get to Copernicus and Galileo?
Then it was Copernicus who had ideas but couldn't prove them. He had no data to substantiate the Copernican or sun-centered model of the universe, which is also, by the way, almost everything in science is wrong, right? Copernicus is wrong. The sun is not the center of the solar system, right? There's the center of our solar system is inside the sun because the planets orbit around it, and they orbit around an elliptical pattern which has two foci. So he believed the orbits were all circles. So he's wrong, but he's more right than Aristotle. So that's why science progresses, right? Newton was right about gravity until he was wrong when Einstein proved them wrong, right? So then you come up to, after him, Kepler discovered the laws of the elliptical motion of planets and their patterns that we still use. We discovered an exoplanet. My colleague David Kipping, I want to introduce you to, he's discovered exomoons. These are moons around other planets, some of which are in the habitable zone of their host star, and some of them have sun-like stars and are Earth-sized planets. It's incredible. There could be, as I said, a link between life evolving on Earth due to the moon on our planet. So too, on an exoplanet, it could require an exomoon, which he's discovered or thinks he has. He's actually very cautious and hasn't said it explicitly. So Kepler's laws underpin all those discoveries, even to this day, 400 years later. Then Galileo, immediately afterwards with the telescope, phases of Venus that only occur if the Earth is not the center of the solar system. The rings of Saturn, he had notions about those. He accidentally discovered the planet Neptune. It's amazing. And then he, of course, the moons of Jupiter falsified the notion that the Earth is the center of the solar system because these moons are going around Jupiter, not around the Earth. So that's completely torpedoed the notion of the true nature of the Aristotelian or Ptolemaic Earth-centered cosmology. Then soon after that, astronomers measured things like the speed of light using eclipses of the moons of Jupiter. They measured distances to Saturn. They mapped out the solar system. And then from there, using parallax, you can kind of gauge the triangulation and using trigonometry, measure the structure of our galaxy. William Herschel and his sister, Caroline Herschel, was the first female astronomer, first female scientist. She was the first person to use the scientific method and become a fellow of the Royal Society in Great Britain. And then later off, after that, we come to the era of the last, the big developments in technology were photographic plates after that, spectrographs, dispersion of light onto photographic material. You could preserve it in memory. You didn't use sketches like Galileo did. And then up until Hubble, when Hubble discovered two major things, which was one was that the Milky Way was a galaxy. It wasn't the entire universe. There were other galaxies, island universes of billions of stars. And then he discovered the expansion of the universe with help from astronomer who doesn't get a lot of attention. A lot of the women in astronomy got really short shrift. People discovered how fusion works in the sun. Women, Gaspachin at Harvard, and then Henrietta Leavitt, who measured this relationship between the size and brightness of objects called Cepheid variables that Hubble then used to make his law that proved that the universe is expanding. And then after that, people like Penzias and Wilson discovering the microwave and radio astronomy, Robert Jansky, all the way up until, my colleagues today, some of whom I've interviewed, Adam Rees and Brian Schmidt and Barry Barish, who wrote the foreword to my second book, detecting gravitational waves, the accelerating expansion of the universe due to dark energy, first Nobel Prize in astronomy, 2011. Followed up 2017, discovery gravitational waves from in-spiraling black holes. There's so many, and there's so many, I've been blessed to know many of them, and I have them as my academic, pedigree.
I'd like to take a quick break and thank one of our sponsors, Function. I recently became a Function member after searching for the most comprehensive approach to lab testing. While I've long been a fan of blood testing, I really wanted to find a more in-depth program for analyzing blood, urine, and saliva to get a full picture of my heart health, my hormone status, my immune system regulation, my metabolic function, my vitamin and mineral status, and other critical areas of my overall health and vitality. Function not only provides testing of over 100 biomarkers key to physical and mental health, but it also analyzes these results and provides insights from top doctors on your results. For example, in one of my first tests with Function, I learned that I had too high levels of mercury in my blood. This was totally surprising to me. I had no idea prior to taking the test. Function not only helped me detect this, but offered medical doctor-informed insights on how to best reduce those mercury levels, which included limiting my tuna consumption, because I had been eating a lot of tuna, while also making an effort to eat more leafy greens and supplementing with NAC, N-acetylcysteine, both of which can support glutathione production and detoxification and worked to reduce my mercury levels. Comprehensive lab testing like this is so important for health, and while I've been doing it for years, I've always found it to be overly complicated and expensive. I've been so impressed by Function, both at the level of ease of use, that is getting the tests done, as well as how comprehensive and how actionable the tests are, that I recently joined their advisory board, and I'm thrilled that they're sponsoring the podcast. If you'd like to try Function, go to functionhealth.com/Huberman. Function currently has a wait list of over 250,000 people, but they're offering early access to Huberman Lab listeners. Again, that's functionhealth.com/Huberman to get early access to Function. Today's episode is also brought to us by Helix Sleep. Helix Sleep makes mattresses and pillows that are customized to your unique sleep needs. Now, I've spoken many times before on this and other podcasts about the fact that getting a great night's sleep is the foundation of mental health, physical health, and performance. Now, the mattress you sleep on makes a huge difference in the quality of sleep that you get each night. How soft that mattress is, or how firm it is, how breathable it is, all play into your comfort and need to be tailored to your unique sleep needs. So if you go to the Helix website, you can take a brief 2-minute quiz that asks you questions such as, do you sleep on your back, your side, or your stomach? Do you tend to run hot or cold during the night? Things of that sort. Maybe you know the answers to those questions, maybe you don't. Either way, Helix will match you to the ideal mattress for you. For me, that turned out to be the Dusk mattress, D-U-S-K. I started sleeping on a Dusk mattress about 3.5 years ago, and it's been far and away the best sleep that I've ever had. So much so that when I travel to hotels and Airbnbs, I find I don't sleep as well. I can't wait to get back to my Dusk mattress. So if you'd like to try Helix, you can go to helixsleep.com/Huberman. Take that 2-minute sleep quiz, and Helix will match you to a mattress that's customized for your unique sleep needs. Right now, Helix is giving up to 25% off all mattress orders. Again, that's helixsleep.com/Huberman to get up to 25% off. Maybe you can help me here. I've never heard a description of the origin of life in the universe that made a lot more sense to me past there were a bunch of big explosions, a bunch of the elements and stuff that you needed came together. And then at some point there was water, and at some point there were critters that moved, and then multicellular organisms. Like, what am I missing here?
Yeah.
I mean, I'm a man of science and I love science, but why can't I can grasp it when it's told to me? But why is it that it's so hard? maybe I'm just not smart enough to comprehend this idea that a star exploded, ... and here we are.
I think it's obvious why you have this particular affliction, and that's because you're used to doing experiment. You're a scientist. Your core identity, one of your core identities is a scientist, right? And you think of things scientifically. And as I said before, the scientific method, as we practice it, is based on hypothesis, observation, experimentation, iteration, right? Well, think about this. If I have a hypothesis that that certain people can detect sunspots, right? So I want to have a control group and I want to have a variable, right? So I want to be able to contrast and see if it's statistically significant, right? And I want a p-hack, right? So what do I have to do then? Well, I have to control the number of sunspots. Okay, sorry, I'm not, you used to say you weren't around at the creation, at the design meeting for human beings.
I wasn't consulted at the design phase. And by the way, when Brian says p-hacking, is people tinkering with the numbers or the experiment or the hypothesis after the data are in order to try and establish statistical significance, which, and by the way, p-hacking is not
steroids.
Not just not good, it's bad. Yeah. It's cheating of a whole, it's not making up data, but it's tweaking the experimental design in hopes that you'll get something where you probably didn't. Yeah, it's not good. You don't want to do it. Don't do it.
Your colleague at Stanford, Guido Mbens, won the Nobel Prize in economics in 2021. And he's done a tremendous amount of work in this, and confounding variables, p-hacking. Where do these things manifest themselves in physics? Well, high-temperature superconductors. This goes back to the late 80s. I remember graduating from high school. There was a discovery of room temperature, what's called cold fusion. That was one thing that would create also limitless energy, too cheap to meter from just using hydrogen and from seawater and palladium and platinum. That turned out to be bogus, and it turned out to be the data were manipulated in such a way that we would say probably fall into the realm of p-hacking, which may not have been maliciously intended, but the goal, the output of it is certainly a driving incentive that influences people to do things that are unethical. And that happens at all levels. And we saw it. I saw it in my own experiment. Not necessarily accusing my colleagues of being unethical. We were searching, and we still are searching, for what caused the Big Bang. We're going to get back to your question of how this comes out, because I think I can help.
But that plate's still spinning in the background,
still
like a planet.
It's spinning like our solar system, right? But the quarry was so big to unravel what caused the Big Bang to bang, what ignited the spark that became our universe. It was called, when we announced the discovery at Harvard on St. Patrick's Day 2014, World News covered front page everywhere, New York Times, CNN, every single outlet covered it. It was called one of the greatest discoveries of all time. Not only did it explain how our universe came into existence, it also predicted the existence of other universes in what's called the multiverse, which we've heard about maybe in quantum computing.
Most people have heard of it on the Joe Rogan podcast.
Yeah, exactly right. That's right. Among many things that we hear about only on that show. So the point is, it was a quarry for the ages, and I knew that because that's why I invented the experiment, right? I told you my father and I, we never really had the rapprochement that you and your father seem to have had, and that's great. We always had kind of a difficult relationship. As I said, he abandoned me. In my book, I write about this rather. He abandoned me and my older brother Kevin at I was 7, he was 10, and he just left us. And because of that, he didn't end up paying child support for me or my brother and alimony to my mother. And so my stepfather adopted us, and my last name was originally not Keating. It was Ax, A-X. And so when we were adopted, I never saw him. I didn't see him for 15 years. But I knew one thing. He was a brilliant scientist, and he was actually the youngest. He was not only a tenured professor, he was full professor with like a chair at Cornell at age 26. So you and I got our professorship like our 30s or whatever.
I was 40 when I got tenure.
Yeah. I mean, it's like he was 26, 27. Now, it was in math. It was a little different. But I knew he won. Basically, there's no Nobel Prize in mathematics. There's the Fields Medal, which is kind of equivalent at some level, but almost nobody knows about it. It's only given every 5 years. You have to be under 40, whatever. He never won that, but he won like the prize just beneath that, if you will, called the Cole Prize. A remarkable scientist, got into incredible discoveries in mathematics and physics. And I knew one thing, he never won the Nobel Prize. So as some kids might compete with their father, who's a captain of the high school football team, and they want to be the captain of the college football, very competitive. Boys can be competitive with their dads, right? You know that. And I wanted to compete with him, but he was an athlete. I wasn't an athlete. I can compete with him and do what he could not do, which was win a Nobel Prize. And I was estranged from him. And I was like, I'm going to win a Nobel Prize and I'll show him, and he'll regret that he abandoned me and gave me up for adoption. This is my thought process. I'm not saying it's like the most elevated way to be, but that's the way I thought of it. So I said, I have to invent something, discover something that's worthy of a Nobel Prize. That's all I have to do, quote unquote. How hard can it be? There's been hundreds of Nobel Prizes given out.
That's the way you thought about it?
I was at Stanford, and you're surrounded by Nobel. You know what it's like. I was a postdoc at Stanford for a short time. We can get into that. And the point was, I was obsessed with discovering or inventing an experiment that could take us back to the primordial universe before what we call the Big Bang. The Big Bang is not the origin of time and space. It's the origin of the first elements in the periodic table of the elements. We still don't know what caused that event to occur. And I realized that if we discovered what caused that event to occur, which is hypothesized to be a phenomenon called inflation, which was co-created by at least 3 scientists, but 2 of whom were at Stanford, associated with Stanford, Alan Guth, who's now at MIT. He was a postdoc at SLAC, and Andre Linde, who's a renowned professor at Stanford to this day. So they predicted that there was this mysterious substance called a quantum field, and that the fluctuations in this quantum field existing in the 4-dimensional infinite space, the random fluctuations of a quantum field, what's called vacuum energy, is unstable. You can't have what's called vacuum or negative energy and have it just sit there permanently. It eventually, inexorably must fluctuate, and the fluctuations can actually spawn an expansion of that 4-dimensional space locally. And that occurred at a specific time.
When you say 4-dimensional space, can you tell us the axes of that space?
So you can think of it as just ordinary 3-dimensional space, but imagine X, Y, and Z extend to infinity in all directions. And we're sitting at our local, what we perceive as the center of our universe. It's just our observable universe. We can look out 90 billion light years in any direction, which is longer than the age of the universe times the speed of light. That's because the universe has been expanding. In addition to having existed for 14 billion years, it's been expanding for that an additional power of 3 times that. And then imagine time. So time is a 4th component, and we have to weave those together in order to understand how objects behave in this landscape of what we call the cosmos. But it wasn't limited to just what we now see as our universe. We have a horizon, just like if you go off to the Pacific Ocean here, away from land, you see a horizon. It's a circular horizon in all directions. So we live on a 3-dimensional planet, right? The horizon is 2-dimensional. It's 1-dimensional, circle that we can see. Any ship that's above the horizon, we can see visible light coming from it, right? But we can perceive that there are things on the other side of the planet that we can't see, and we have to learn about those through indirect methods. We can talk about that at a different time. So there's a horizon on a 3-dimensional surface. That's a 1-dimensional surface. In 4 dimensions, it's a 2-dimensional surface. So you kind of lose 2 dimensions. And that means it's a sphere. It looks like our universe looks like a sphere centered on us. We look in all directions. We see constellations. We see galaxies. We see clusters of galaxies. If you go far enough back, you see this primordial heat that's left over from the formation of the elements. That's called the cosmic microwave background radiation. That's what I study, its properties. And what it reveals is the oldest light in the universe, the oldest possible light. It was once visible. You could see it if you existed, but nobody existed back then. And it originates from the formation of the lightest elements and the lightest atoms on the periodic table. So you could look back, and if you could see this, you would see a pattern imprinted on that light called gravitational radiation or waves of gravity. And that would be evidence of something beyond the visible horizon. And that would actually originate from this inflationary epoch, if it occurred. So I had the idea to build the first telescope, a refracting telescope of all things, just a telescope with lenses, but lenses that are transparent to microwaves and focus microwaves. But I realized I could build that telescope. And if we were successful, I didn't think it wasn't guaranteed to be successful, but it was a big enough scientific quest that it was guaranteed to win a Nobel Prize if we were correct. And in fact, spoiler alert, my first book is called Losing the Nobel Prize, because we had to retract the discovery that we made at Harvard on St. Patrick's Day 2014, 10 years ago.
So you had a paper that essentially led you to the realistic possibility that you might win the Nobel Prize.
Yeah.
And then you had to retract it. Do you recall your emotional state or state of mind when you realized that you were wrong?
Very clear. And that's how it relates to this p-hacking and everything else. We actually didn't have this paper peer-reviewed. We were so concerned that a competitor which is a spacecraft, $1 billion spacecraft. We were just a $10 million experiment, a little telescope at the South Pole, Antarctica, where I've been a couple of times. And that instrument bested a scientific telescope led by 1,000 people, costing $1 billion, led out of multiple countries in America and Europe. And we were terrified, as many scientists are, that we're going to get scooped. In fact, the original discovery of the cosmic microwave background was made by accident. The discovery of this 3 Kelvin heat source that's coming to us in all directions, i.e. it's a background, was made by accident at Bell Laboratories. And Bell Labs accidentally discovered it because they were looking at the very first communication satellites. AT&T, Bell Labs is a communication.
So they stumbled on it.
They accidentally said, I'm looking at the satellite that should have a certain amount of background, hiss, noise, whatever that was expected, but I'm getting hundreds of times that amount. And where could that be coming from? They did very excruciating, very high precision measurements, and they found they couldn't identify a single terrestrial source or a cosmic source of any other sort, except for the fact that if the universe began essentially with a big bang, they didn't call it that back then, that there would be a pervasive heat left over that would be exactly this temperature, 3 degrees above absolute zero, 3 degrees Kelvin. So I knew if they won a Nobel Prize, certainly I'd win a Nobel Prize for discovering why that effect happened, right? It's like you discover, some amino acid, and then you discover, well, it's produced by DNA. Well, certainly if the amino acid won the Nobel Prize, certainly DNA would win the Nobel Prize,
hence
right?
Arthur Kornberg RNA structure of RNA.
Yeah.
So you published a paper that wasn't peer reviewed.
Correct.
Because you were worried about
getting
scooped. Scooped is when someone else beats you to publication, folks, and gets credit for the discovery. It's a whole discussion that we could have some other time if we just want to riff on the process of science. But so you published the paper.
Yeah. We didn't publish it. We submitted it to the archive. We had a press conference at Harvard Center for Astrophysics and Space Sciences. And it was televised. And in the audience were Nobel laureates and reporters. But the discovery that, it was clear that we would have won it. However, at that time, I had been removed from the leadership of the experiment that I created. So I created the predecessor experiment. It's like iPhones. You build one, then you upgrade it, you build a better camera, blah, blah, blah. So the first one I invented when I was a postdoc at Stanford, it was called BICEP. And it stood for Background Imager of Cosmic Extragalactic Polarization. And it's also kind of a play on words because the pattern of microwave polarization, which we can talk about, was a twisting, curling pattern. So I made the pun, like a curl, like you do bicep, the muscle behind curls. Anyway, it's not that funny, and they ended up trying to change the acronym, which pissed me off. But anyway, the tragic thing is that we built this experiment, we upgraded this experiment. It was very hard to get money to build it. I got money from David Baltimore, who's the president of Caltech. I should say I was at Stanford.
I should say about David Baltimore, just because people might want to go to. Former president of Caltech, maybe still?
Rockefeller? No, he's not.
Former president of the Rockefeller. Yeah. That's an interesting story. Yeah. If you want to look it up, look it up, as they say.
Exactly.
Scientists are human. He landed at Caltech.
Yeah.
So they funded you to do this?
He gave me a special grant, just presidential. It's called Caltech President's Fund. He gave it to me and my postdoc advisor, Andrew Lang. He's an incredible scientist. He was married to Frances Arnold, who won the Nobel Prize in 2018. In chemistry, renowned scientist as well. And they were just a power couple. And he invited me to give a talk, and I gave a job talk. He hired me on the spot. I couldn't, help myself from saying yes before he finished this. I was miserable at Stanford, by the way. It was 1999, 2000, dot-com boom. I was making $32,000 a year, living on Alma Street. The Caltrains were running every 17 minutes. I know because I was awake from 5 a.m. I couldn't sleep more than 4 or 5 hours. And I just said yes, moved down to Caltech. And because of that, I convinced him and my colleague Jamie Bach, who's currently a professor, to build this telescope and put it at the South Pole in Antarctica. And that was the only place we could do it. And the only university that would fund it was this gift from David Baltimore's presidential fund. So these confluence of events. And by the way, then because I had this job and because I built this telescope with my colleagues, I got the job at UCSD, which then enabled me to meet my wife.
So let me, incredible story. You moved down to Caltech, which is in Pasadena, amazing place. And then you get the money. How much was this telescope?
The initial one was $1 million to build the first version.
Okay, that's quite a gift for a postdoc.
Yeah,
$1 million bucks. You decide the South Pole will be the place to do it. We can talk about why that is.
Yep.
And then you make this discovery, which turns out to be false.
Yeah.
So, but it sounds like you have good feelings about the experience nonetheless.
So because I was recognized and this experiment got a lot of attention because it was really the first one ever designed to look for the spark that ignited the whole Big Bang. So it became, just the cause célèbre of the cosmology field.
And are you thinking at this point, forgive me for playing therapist here, I'm not one, I'm not pretending to.
No, it's fine.
Were you thinking at this point, okay, this challenge that I think not all but a lot of sons have with their fathers, not necessarily to best them, but one evaluates themselves relative to like their family lineage. Yeah. Sometimes it's a grandfather. This thing of having some internal friction in order to live up to something. Yeah. Sounds like that was driving you.
When you made Tiger Woods, another Stanford guy,
right?
Same story. But father, hard pushing, driving. And then what does he do after he, is a PGA champion? He wants to like become a Navy SEAL or something. Like
he was hanging out with a lot of SEAL teams.
It wasn't enough for him. Sorry, I interrupted your question.
No, so at the point where you made this discovery, were you feeling like, all right, check that box?
What was kind of revelatory to me is that sometimes you start a quest or you start a journey, and the fuel that gets you going, this no longer serves you when you get there. My brother always says, baggage has handles, so you can put it down.
Nice.
So that like journey from initiating it, the experiment, to best my dad, to show him up, to make him regret that he abandoned me and my brother. I mean, I always said I could see he could abandon me. I was only 7, kind of boring. He used to joke, I only care about kids once they learn calculus. He was kind of funny.
What a cruel thing to say.
He would say it in jest, and it is true. We did reunite, and we did have a rapprochement, but it was after inventing this experiment, after I arrived at Caltech. It was. I mean, he was this kind of intellect, and it was so lovely to see you and your dad. My wish for you is to have kind of an experience, maybe similar, maybe not, but when you do have kids, and please God you will, you get a do-over. You get to kind of correct the mistakes or the ways that and you'll never get it right. One of my friends is a psychiatrist. He says your job as a parent is to only pass on half of your neuroticism to your kids, and if every generation does that, we'll eventually be a perfect species. But I felt that passion and so forth to kind of best him, and then when we reunited, and it no longer, as I said, it no longer served me, but the trajectory that I had launched this experiment on continued unabated. And so that had this inertia, this momentum that couldn't be stopped. In fact, so many people wanted a part of it, and so much pressure was surrounding it that I think, partially that led to me actually being kind of kicked out of the leadership of the experiment. And that was precipitated by a truly tragic event. So I told you, my advisor, Sarah at church, set up a job interview for me with her advisor when she was a postdoc at Caltech named Andrew Lang. Andrew was like at that time I was estranged from my dad. He was like a father figure. He was like, like you ever see the TV show Mad Men, like Don Draper? He's just like handsome, good looking. Everyone thought he was going to win a Nobel Prize. He was stolen from Berkeley. They spent tons of money to recruit him from Berkeley to come to Caltech. He only can't, his wife was a power couple, Frances Arnold. Again, she won the Nobel Prize a few years ago. And he just had the world at his fingertips, charming, funny. And he would say things like, Brian, this is so unrealistic that we have to do it. Like, he was a kid. He loved to play, and he's the one who inspired me in this way of just never stopping, like that passionate curiosity and the reward that you get. I always say, when you solve a problem, your reward is a harder problem. Like if you're a scientist, that feels good, because it's like, I always say, and I think it's one of your colleagues, so I'm not sure. So much good stuff going on up there, but there's this concept of finite games and infinite games, right? So I always say science is an infinite game. You can't win science. It goes on forever. No one masters all of whatever science is. You can debate even what it is, but it's composed of an infinite number of finite games. Getting into college, getting into graduate school, getting a postdoc, getting a tenure track position. Those are all finite games, right? And what's the ultimate finite game? A Nobel Prize. Because only 3 people can win it each year. There's only 200 people have ever won it. There's more people in the NBA than have won it in physics, right? So this is a very exclusive club, and if you win it, somebody else isn't going to win it, right? Odds are. And this pressure to kind of get to that level should never exceed the passion that drove you to become a scientist in the first place. And so I was obsessed with that. And what Andrew Lang showed me is that science is its own reward. And the pleasure of finding things out, as Feynman would say, is its reward. Science is its own reward, and that's characteristic of these infinite games. You just want to keep playing them. And the tragic thing is that, I'm emotional thinking about this, when Andrew was at the peak of his life, he chose to take it. He took his own life.
He killed himself.
He killed himself. Ironically, tragically, he used helium, which is central to the formation of the universe, and the creation of our universe is reliant in large part on helium, the abundance of, and he asphyxiated himself in a cheap, dirty, sleazy motel. Actually, I had stayed at in Pasadena when I was visiting him for my initial job talk.
Do you mind if we go into this a bit?
Yeah.
I realize it's a painful memory, and I feel it. Not to shift the focus, but ironically, all three of my academic advisors dead. First one shot himself in a bathtub 2 weeks after we celebrated something for him. Just suicide is such a peculiar thing. He did it for very different reasons, different stage of life. Let's get back to Lang. How old was he?
He was 41, I think.
So he's young.
He had 3 kids.
Is his
three sons.
Wife still alive?
Yeah, Frances still a renowned professor.
Was she shocked?
They were separated. They had gotten estranged, and they weren't living together. It was interesting. He was always very close with. She had 2 children, I think, from a previous marriage, or 1 child from a previous marriage. And he was like a father to that son as well, like a biological father, whatever that means. Kids were so dedicated to him. And look, don't cry for me. I mean, I still emotional because he meant so much to me as a mentor, as a friend, as an advisor, as a father figure, basically. But he had real kids, and he had adopted kids. And
it was tragic for everyone. Suicide is such a peculiar thing because it, in some sense, it can quote unquote make sense for if somebody we know is very depressed or they have a terminal illness, but it sounds like it came as a bit of a surprise. Do you think that sometimes there's this close relationship between genius and let's just say not mentally healthy? That even what you mentioned before, like we have to try this experiment. Yeah. I mean, there's a bit of a recklessness to that when you're dealing with millions and millions of dollars in postdoc careers, and that there's the delight of a fun experiment and an adventurous experiment, maybe as a project where you kind of wade into it a little bit to see, but that's very different than like we have to do this.
Yeah,
I mean, there's a risk-taking element there that supersedes kind of my notions of like what an advisor's job is, which is to make sure that people progress toward discovery, but also like you want some. One of the most important things to mentoring scientists is that they have some sense that there is a future for them. Yeah. And you can't guarantee it, but you'd like to, like a parent would for a child, you want to give them some sense that like the sun's going to come up tomorrow.
That's right.
We're not going to implode or explode here.
And he was a pragmatist. He would give me advice, life advice, and again, I was estranged from my father. He was playing this role. And he was just he was charming. I mean, he was handsome, charismatic. He had just discovered, came off this discovery of proving that the universe has a flat spatial geometry, which just means that any triangle that you make in the universe, whether it's 3 planets, 3 stars, 3 galaxies, 3 patches of the cosmic microwave background radiation, always the interior angles add up to 180 degrees, as they do on a flat table here, as they did for Euclid. And that had astonishing implications for how the universe might have begun.
And it's still true.
And this is still true. It's more true than ever.
So do you think that perhaps, I mean, who knows, perhaps he committed suicide because he was at a peak? One of the things that people talk about is the peak and trough of dopamine. You mentioned infinite games. That I've said many times before that it's very important that you not get fast, large amplitude increases in dopamine that are not preceded by effort. Yeah. Methamphetamine will give you a large amplitude, a fast increase in dopamine, but there's zero effort involved except to procure it, and it sinks you into a post-dopaminergic peak trough afterwards that will have you hanging on for the will to live. So what comes up goes down, and it often goes down further than it went up when we're talking about dopamine. Playing an infinite game is great because it's in the motivation for answers. It sounds like he hit a peak, and you wonder if maybe he was like, okay, now I'm going to check out now. It's going to be hard to keep doing this.
I don't think it's explicable. I don't think. I mean, the human brain is the most complicated thing, and the human brains can even contemplate. Right? It's solipsistic in a sense, but I couldn't really wade into it. I mean, I know details of his personal life, and yes, divorce and separation and so forth. But I don't think that's it. Just because the highs of the new quest and like the dopamine hadn't really come in from BICEP, and it wouldn't come in for 4 more years after his death in 2010.
So you got to continue the project.
We got to continue the project, but because he was removed and he was kind of my consigliere, whatever I was to him, I forget how the relationship goes. I'm not as conversant with the mafia as I should be. But with Andrew, with his death, one of the trivial in comparison consequences was that the main patron and backer of me in my career, who had helped me get my job at UCSD, had helped me get this presidential career grant, which I received from President Bush, and all these incredible accomplishments, and just been my sounding board on experiments and kept me going and helped me when I had troubles with my graduate students. And he would talk to it's unheard of, right? The compassion that this man had, and if he had only reached out to me, I'm sure he had better friends than me, but like I would have gone up in a second. I went to the motel where he took his life when I was writing my book, just to put me back in, like, how could I comprehend it? I couldn't. I just cried. I sat in front of the hotel and I cried. But no, I don't think we can understand it. But the eventual high wouldn't come, and then a much more crashing low after we essentially had to retract it and we're disconfirmed, as they say.
So you continued with the project.
Yeah. I was at UCSD and I'd left Caltech.
You get your job. You got this telescope down at the South Pole. How do you get to the South Pole? You fly to Chile,
really
and
cool.
then you ride a bicycle
it's
down?
Like, I never had the physique to get into the military, although I wanted to at one point to be a pilot. Actually, I wanted to go to the Air Force Academy like my stepfather did. But I didn't have the physique. I didn't have the HLP diet back then. But the point was, you go on a military. It's a whole way, and you do it in 7 days, 8 days, if you're lucky. Sometimes it can take 3 weeks due to the weather down there. It's the most violent weather, most winds, turbulence, everything hostile. But it's a cakewalk compared to the explorers, Shackleton, or Scott, and of course Amundsen. So the quest to get to the South Pole first, which is South Pole, I should say for people that aren't familiar, Antarctica is the 7th continent. It's the last one to be discovered. It was only really discovered, it was thought to be there because it was thought that to balance the continents in the northern hemisphere, you needed a massive counterweight in the southern. It's so stupid. But anyway, it wasn't discovered till 1900s, really, that they truly existed. And then it wasn't explored until 10 or 12 years later. And the quest to get to the South Pole, it was the last unexplored, non-filled in part of the map of the Earth. So the quest to get there was like going to the moon. And in fact, it exactly parallels the moon in that once it was reached for the first time, nobody cared to go back again, for many, many years. And we're only going back to the moon now, 60 years later, 50 years later, after the Neil Armstrong and the Apollo 11 missions, right? So getting there and setting that bar, right, and making that accomplishment, sometimes that's the extent of it. Like when you have that dopamine hit of being the first to get somewhere. Scott was a British scientist and an explorer, and Amundsen was just an explorer. Roald Amundsen, he tried to get to the North Pole first. He lost. Somebody else beat him. And he said, well, I'm going to keep going with this ski and sled dog team that I have. And he literally went to the South Pole, 180 degrees around. So the poles are the two endpoints of the Earth's axis of rotation. There's a North Pole. There's no land there. There's no continent there. There's ice there. And Santa is there, exactly, right? And then the South Pole is a continent. If you go, I brought a piece of it here that I collected, probably illegally from Antarctica. I'll show it to you later. It's just rocks, right? So if you drill under the ice in Antarctica, you come to a continent. And that's the difference between the North and South Poles. But the South Pole is 700 nautical miles from the coast of Antarctica. The closest point of approach in the 1900s was you take a ship from New Zealand, you sail due south, there's no other way to go, and you come to the continental shelf. The coastline's called McMurdo Station, which was just, basically there's some sea lions there and that's it, and orcas and penguins and nothing else at that time. Now there's a whole research station. And then they got on skis and skied up 9,000 feet from sea level to 9,000 feet where the polar plateau flattens out. And they got to the South Pole. And Amundsen got there 3 weeks before Scott. And Scott was this British, naturalist and like a Darwin, but also he was a scientist plus an explorer. So he wanted to collect samples and he found flora and fauna. There's not much. Rocks, meteorites. He actually discovered meteorites in Antarctica. Incredible scientist. But because he was a scientist, it cost him his life. Because he was carrying all this scientific equipment and scientific samples, and he had to ski up them. Like, he would find it, and he's like, I'm not coming back the same way that he got there because of the wind patterns and stuff. So he knew he'd never come back, so he couldn't leave it there. So he had to carry extra food, fuel, and men dedicated to it. Oh, and by the way, the Norwegian team, Amundsen was Norwegian, and they used sled dogs for two reasons. One, they conserved calories, they provided propulsion, and then they provided a tasty snack once you got to the South Pole. Because once you get to the South Pole, you can ski downhill 9,000 feet, to sea level, basically. And so they ate, British would refuse to do that. So they knew they couldn't eat their dogs, and they had dogs, but they wouldn't eat them. So they were the sled dogs. And when they got to the South Pole, they came within 3 or 4 kilometers, and it's totally flat like this table. The South Pole looks like this. Go out in the middle of the ocean, freeze it, paint it white, and that's what it looks like. It's white, 360 degrees around. Okay, it's the most boring place on Earth, literally, and I've been there. He got within, so you can see things really far away. He got there, he got within 3 kilometers, and he saw something on the horizon. He's like, oh, bleep, right? And it was a Norwegian flag. Now, can you imagine Neil Armstrong steps out of, the Eagle, and he lands on a Soviet flag? I mean, it would be like the most crushing, it was the most depressing moment in human history to come so far. And he actually said, they said, great God, this is a horrible place. And all the more so for having reached it without the benefit of priority. So the king and queen, they were depending on him to make the first, for king and country, right? Seeing the Norwegian flag. So what did he do? He was a good scientist. He said, maybe they made a mistake. Maybe they're off by 10 feet. I can say, no, they were right. The Norwegians got there first. And because he got there 3 weeks later in the middle of January, by the time he turned around, the winds had died down. They were no longer at his back. He was skiing. He had no food. He died about 3 weeks later, or 3 months later in March. So his body was later recovered, and it was it wasn't reported back to England for another 6 months. So they gave their lives for science, for discovery, and to come up short to be second, it must have been the most crushing defeat in history.
Whoa.
But it happens to be the best place to do astronomy in the world.
And you get there by flying to Santiago, Chile?
No, first you go to Christchurch, New Zealand. You go to Auckland,
okay.
LAX, Auckland to Christchurch. And then the U.S. Has a charter with the New Zealand Air Force. And we give them C-130 cargo planes, or we have our own C-17 cargo planes, the jet-powered ones. Unfortunately, I got the C-130s, which is a 4-prop plane. And I was on a plane that had the entire winter supply of bananas on this cargo plane, which is as big as this room, the cargo hold, 12 by 12 or, times 50 feet long. And it was filled with bananas. And at first you're like, oh, cool, this is great. Until you realize there's no bathroom on the plane. There's just literally a 5-gallon bucket and a shower curtain. There are no windows on it because why do paratroopers need windows? And then there's just enormous crates of bananas. There's 12 tons of bananas. I have not touched a banana in 12 years because of that. I know I'm missing potassium or whatever. But the point is, you land on the coast, and then if you're lucky, you take a flight the next day, and it's a ski plane. It's the only plane that the U.S. does not export. In other words, we export the F-35, this is a strategic asset that we will not export.
So it's hard to get to.
It's very difficult.
So why South Pole?
Yep.
And does this take us into the realm of light pollution?
Yeah.
Right? I mean, when I look up at the starry night here in Los Angeles, even though I'm sort of back towards the eastern hills, I don't live at the coast, I can see some pretty impressive stars. Mm-hmm. Not as impressive as when I highly recommend people get up to the Yosemite High Country in the month of August. You can catch some great meteor showers. Yeah. It's an amazing place to begin with. You have the meteor showers, and you're transported to another place.
Yeah.
And there's a lot of light pollution from cities. Yeah. And it travels very, very far. So I'm guessing you're down the South Pole because there's less light pollution.
You're right. A slight deviation from that is it's not light that we're looking for. We're not looking for optical light. We're looking for heat. So it's heat pollution. You're exactly right. We're looking to avoid heat pollution. So we want to be somewhere cold. We want to be somewhere that's far away from, man-made sources of RF interference and microwave interference and communications, obviously. But the South Pole has a couple of other properties. One, the sun is below the horizon, and the sun is 5,500 Kelvin. And we're looking for something that's a fraction of a Kelvin, maybe a few milli or nanokelvin at most. So it's billions of times that we want to avoid. Even the Earth itself is still 300, almost 300 Kelvin down there. Yeah, freezing is 273. So it does have that property. But the best part about it, it's above a lot of the Earth's atmosphere because it's at 9,000 feet above sea level. And it's so cold. You don't know this because you're a California baby, but on the East Coast, when I would grow up, some days the bane of my existence would be you'd listen on the radio and they'd announce school closures due to snowfall in the winter. And sometimes they'd say, "Oh, you're out of luck because it's too cold to snow." Sometimes the air temperature cannot saturate and form precipitation, and the South Pole is like that. It's so cold that if you took this glass, I'm holding a glass here, and it was empty on the table here, and I extend this glass up to outer space, the amount of water, if I took all the water in the atmosphere, the humidity in the atmosphere above the South Pole, and condensed it into a liquid, it would be a 0.3 of a millimeter. Here in Los Angeles, it's about an inch or 25 millimeters or more. And so you'd like to not go there. Now, why is that important? Well, water absorbs microwaves, and that's how your microwave oven works. It heats up the water molecules. They start to vibrate and jumble. That causes friction. They heat up and eventually they'll boil, right? So that's why sometimes you can, overheat liquid in a microwave. You can't tell, but it's super hot and actually it can be dangerous. But in this case, we don't want a photon coming from the Big Bang perhaps, or before the Big Bang with the spark that ignited it. We don't want that to travel for 14 billion years nearly and then get absorbed in a water molecule above the Earth's surface. So the best place to go is space. But space, even with SpaceX, I haven't done any scientific experiments, but it's about maybe a factor of 1,000 to 1,000,000 times more expensive. So the same satellite that we were worried was going to scoop us was exactly 100 or almost 200 times more expensive than our experiment at the South Pole.
Yeah, I was going to ask you about this. $1 million given to a postdoc.
That was the first tranche of funding. We ended up getting about $10 million.
$10 million. I mean, even $10 million is a lot of money by any standard.
Yeah.
But probably, to my mind, doesn't seem like enough money to build a high-powered telescope at the South Pole, bring people there, have the infrastructure. I mean, it's not like you're rolling this thing out onto the ice and just pointing at the sky. I mean, you need.
Oh, it's true.
I guess you could use the bucket from the plane as a bathroom, but you need a number of things. So, you probably need hundreds of millions of dollars to build a facility down at the South Pole.
But those are all funded by you and your listeners and so forth, the taxpayers. So the National Science Foundation, it operates, those C-130s are part of the National Science Foundation's fleet. We don't pay a dime for them. If I want to build a computer network system down there, we don't pay a dime for it. It's actually a point of contention because now I'm no longer with that experiment. I've recused myself from it. For many years, not because of the incident where we, were basically later disconfirmed our result.
Right. So you let the result out. You do this news conference.
I didn't do the news conference.
Okay. So it was a big press conference. Yes. Big press conference.
That's right.
It turns fast forward some years, it turns out this was not correct.
Some months, yeah.
Only
a few months.
Not correct. Well, better to be corrected quickly than, and collect your Nobel Prize and have to give it back or something, right? I have to say, and the pursuit of prizes is a complicated thing.
Yeah.
I was always discouraged from pursuing prizes.
Really?
All my advisors.
Well,
my graduate advisor was very pure in the sense that she just liked doing experiments. I remember she was very, very smart. Very smart.
It's Barbara
Chapman. I mean, it's not just her pedigree that is evidence of that, but since pedigree is something most people can at least understand internally and externally. I mean, she was, went to Harvard as an undergraduate, then she was at UCSF and Caltech, and she actually had a project sending zebrafish up into space, looking at development of the vestibular system in the absence of gravity.
Gravity, wow.
And then fixing these specimens and bringing them back. Also did a lot of great work back on Earth, but she wasn't somebody who was ambitious for ambition's sake. And then my postdoc advisor was exceedingly ambitious, but he also discouraged prizes and the pursuit of prizes.
That's the right way to be.
Yeah, I think that it's sort of like going into football to get a Super Bowl ring. These things do represent the pinnacle, but it's dangerous to be chasing that like singular carrot because you can miss the journey.
Look, I'm not proud of that. I'm not proud that I had such a base venal, kind of pursuit. I think it was, as I said, compounded by psychological factors,
But did you have fun doing the work?
Oh, I loved it. Yeah. I mean, getting to do what I do now, and now it's even more exciting in a sense because the project, and by the way, it's not like we made a blunder and Rob hopefully took the lens cap off the camera. We didn't make a blunder like that. There have been many, many blunders and actually led to much worse retractions. Our results are stronger than ever. I should say, the BICEP team's results. I've left the team, as I said, but their results are still the very best by almost an order of magnitude. We hope with the Simons Observatory that I'm, co-leading with colleagues at Princeton and Penn and other places that we can actually supersede them, but we haven't yet. And so what we saw, I should be very clear, we didn't make a blunder. We didn't put our thumb in front of the viewfinder. We didn't make something stupid. We mistook a signal produced by another astrophysical source as representative of this curling pattern of microwaves for which BICEP was named. Mm-hmm. That would be indicative, if confirmed, of the inflationary origin of the universe, which, by the way, would be concomitant with the existence of the multiverse. So the stakes are really high. That means the incentives to make sure you detect that are really high too, and not get scooped, as happened many, many times. My advisor was scooped. He never won the Nobel Prize. My advisor's advisor. He never won the Nobel Prize. These accidentally discovered, serendipitously discovered astronomers, Penzias and Wilson, they did win the Nobel Prize. So there is a pressure on scientists to get there first, like Robert Scott getting to the South Pole first. There is a benefit to priority. It's just a fact of life, and science is no different. We teach undergraduates about 7 or 8 different experiments. All of them won the Nobel Prize at some point in physics history. Doesn't mean they're going to win a Nobel Prize. No. Why? Because they didn't get there first. So getting there first in science, that's for better or for worse, is the sign of the greatest accomplishments, the sine qua non of accomplishment is that does lead to Nobel Prizes. Now,
but the goal is always, I have a motto, which is, go as fast as you carefully can.
Yeah.
But it sounds like you were wrong for the right reasons, meaning no one made up data.
Yeah.
There was a confound that you weren't aware of.
Yeah.
You became aware of it.
Yeah, I should say what we saw. What we mistook as the imprimatur of this origin spark of the universe was the humblest substance in the universe, namely dust. So when a star explodes, it produces, after its lifetime has expired, it fuses lighter elements into heavier elements. Eventually, it gets to produce iron. And iron is the element for which, once it's fused together from, I think it's silicon or 2 nuclei before it, it produces too little energy to keep the star buoyant and expanded. And so the star immediately starts to collapse. When that collapse occurs, it blasts out into the interstellar medium that surrounds it, all the byproducts, the silicon, nitrogen, oxygen, hydrogen, and the iron. And it blasts it out into the universe surrounding it. And that happens enough times in our galaxy that the galaxy is actually a pretty polluted place. It's smoggy, it's dusty, it's dirty, and the dust is actually little microscopic meteorites. So on my website, briankeating.com, I give away, actually I have a special link, briankeating.com/Huberman. I will give away actual meteorites that come from your ancestral homeland of Argentina. And you'll see when you get them, they're highly magnetic. They're very dense, and I give you the material, the composition of these meteorites and the assay. We do X-ray crystallography on them. It's really cool. The actual composition of them is determined by this last event that a star does before it dies, which is to produce iron. So we did discover a microwave signal from the galaxy, not from the Big Bang, not from the cosmos, but from particular and unique to our galaxy, which is that when a star explodes, it produces this material, mostly made of iron, the micrometeorites that I talked about, put on my website for your listeners. And these micrometeorites are also going to act like little compass needles. They're highly magnetically susceptible. So the Milky Way, everything in the universe has a magnetic field. You have a magnetic field, birds have it, even bacteria can have it, and our planet obviously has it, and the galaxy has it. What happens when you put a compass in a magnetic field? Those needles get aligned with the magnetic field. That then produces a type of polarization. Now, polarization is the least familiar. Light has 3 characteristics. Its intensity, its color or spectrum, and its polarization. almost nobody knows what polarization is, but it's really the essence of what makes light a wave. If you think about an ocean wave, the ocean wave is going up and down, undulating up and down, and the undulation, the direction perpendicular to the sea surface, is its polarization. Happens to be that water waves are actually polarized longitudinally, but forget that. Or if you and I, separated by 1.5 meters, 2 meters, we have a rope between us. If we oscillate that rope up and down at a certain frequency, the frequency would be the spectrum, the color of the light. How hard we do that would be the intensity of the light. And the plane that we're oscillating, the jump rope or whatever, that's the plane of polarization. These little needles of cosmic dust from the exploded innards of a star that died in our galaxy many years ago, and many, many billions of these stars, they produce these particles of dust. So we saw that pattern instead of seeing the birth pangs of the Big Bang, the origin of the universe.
I'd like to take a quick break and thank one of our sponsors, ROKA. ROKA makes eyeglasses and sunglasses that are of the absolute highest quality. I've been wearing ROKA readers and sunglasses for years now, and I love them. They're lightweight, they have superb optics, and they have lots of frames to choose from. I'm excited to share that ROKA and I have teamed up to create a new style of red lens glasses. These red lens glasses are meant to be worn in the evening after the sun goes down. They filter out short wavelength light that comes from screens and from LED lights, the sorts of LED lights that are most commonly used as overhead and frankly lamp lighting nowadays. Now, I want to emphasize ROKA red lens glasses are not traditional blue blockers. They're not designed to be worn during the day and to filter out blue light from screen light. They're designed to prevent the full range of wavelengths that suppress melatonin secretion at night and that can alter your sleep. So by wearing ROKA red lens glasses, they help you calm down and they improve your transition to sleep. Most nights I stay up until about 10 p.m. or even midnight, and I wake up between 5 and 7 a.m., depending on when I went to sleep. Now I put my ROKA red lens glasses on as soon as it gets dark outside, and I've noticed a much easier transition to sleep, which makes sense based on everything we know about how filtering out short wavelengths of light can allow your brain to function correctly. ROKA red lens glasses also look cool, frankly. You can wear them out to dinner or to concerts or out with friends. So it turns out it is indeed possible to support your biology, to be scientific about it, and to remain social after all. If you'd like to try ROKA, go to roka.com, that's ROKA.com, and enter the code Huberman to save 20% off your first order. Again, that's ROKA.com and enter the code Huberman at checkout. So I want to talk about what you're working on now. Before I do that, right? Mini segue. There are a number of questions that I have, that some of which I sort of know the answers to, most of which I don't know the answers to, but I think a lot of people either wonder about, or if they don't, they can quickly enrich their experience of daily life if we were to get answers on the following. So I'm thinking about this not rapid fire Q&A, but maybe like 1 to 3 minute answers about the following. For instance, why does the moon look so much bigger when it's near the horizon as opposed to overhead?
Yeah, my son asked me that 2 days ago.
So that's a fun one. So let's go first with that. Sometimes the moon is huge. Sometimes the moon is small.
Right.
And I'm not talking about when it's full versus a sliver.
Right.
Tell us why.
So the moon is always a half a degree wide, same exact apparent angular diameter as the sun, which is unique among the 290 moons in our solar system. Only our moon has the same apparent diameter as seen from its planet as the sun does, meaning we're the only planet that can have a total solar eclipse, an exact total solar eclipse like we had a couple of months ago in Austin, Texas, and elsewhere. Be that as it may, the moon doesn't change its size.
I would hope not.
Yeah, exactly.
That would freak me out.
The moon is about 60 times the Earth's radius from the Earth. It's 250,000 miles away, which is about 1.5 light seconds away. And it is about the size of the continental U.S. in diameter. So, or a little bit less. So the moon's size doesn't change, but when the human eye has something to compare it to, the brain has a reference point to compare it to. And because it's so big, if there's something in front of it, a 747, a person, a large building even, if the moon is behind that object, because it's so far away, moving even the Earth's entire radius doesn't change the moon's apparent angular diameter. It's the same in Peking as it is here, Beijing as it is in Los Angeles, right? So that means a very large change in the distance in the Earth would change the building size dramatically. It could reduce it to zero, basically. But when you compare it to something that's close on the horizon, your brain has something visually to compare it to. When it's overhead, in zenith or whatever, it doesn't have anything to compare it to, so you're just looking at it. But you can always measure it, and you can prove to yourself it's always the same size. It's about the size of your pinky fingernail held at arm's length. Same size as the sun. And interestingly enough, it's
You said 1 degree.
It's half a degree.
Half a degree.
Half a degree, yep.
Oh, that's why you said pinky. So folks, most people probably aren't familiar with thinking in degrees. If you want to understand a degree, put your right or left, doesn't matter, arm out in front of you. Raise your thumb like a thumbs up. So at the width of your thumb at arm's length is approximately 1 degree. That's why you say for your pinky, it's about half a degree.
That's right.
I should also say, and this is an opportunity to give a fun little lesson in visual acuity. If I were to draw 30 black lines spaced from one another with just the light color of your nail in between them, we'd say there were 60 lines, black nail, alternating. Your acuity for 20/20 vision is approximately 60 cycles per degree.
Yes.
A hawk, any kind of raptor, is about 120 cycles per degree, which is why they can sit up on a lamppost and actually see the rustling of the grass below and probably make out some of the individual furs on the head of a rodent.
Wow.
But you can't. So what do I mean by 60 cycles per degree? If I were to draw 40 black lines, so now you have 80 total of black, and then the color of the nail black, then the color of the nail. So you would see that as, believe it or not, as solid black.
Right.
It's you don't have, it's beyond your acuity threshold.
Right.
So when you say 1 degree, so this is important. Yeah. So when the moon is quote unquote giant at the horizon, put out your pinky.
Yep.
It covers the moon.
You can eclipse the moon.
You can eclipse the moon. When the moon is overhead,
Yep.
you can eclipse the moon with your pinky.
Fun
and
fact.
most people are probably thinking, no way, that can't be true. But
Yep.
it's absolutely true.
Fun fact, which is bigger, the width of a rainbow or the width of the moon? And is a rainbow wider than a half a degree? You ever seen a rainbow? You can visualize.
I mean, in the sky, it seems as...
I'm not talking about the arc, the band thickness from red to blue,
right.
or from red. Yeah.
Roy G. Biv.
Roy G. Biv, yeah. What's bigger?
Gosh, intuitively, I want to say it's thicker, but now you're going to tell me that it can't be because it's. This is like the Pink Floyd album, right? This is literally just the polar
dark side of the moon.
The dark side of the moon, the rainbow coming through when you take light and pass it through a prism.
Right? Yeah.
I'm going to say it's 1 degree.
So the rainbow's bigger?
No,
the moon's bigger.
It seems like roughly the same size, but when I think of a rainbow, I just think of like the
no, you're right.
large
It's the same size.
Okay.
It's the size of the sun. Which is
okay, so it's a trick question.
Exactly, that's right.
Thank you very much.
There you go. Professor passes the test.
For once.
Yeah.
Okay, next question. People obsess over this. I have my theories. I think it's still debated. When you watch a sunset, you get that beautiful long wavelength, short wavelength contrast that I blab about incessantly on the podcast and social media because that's what's setting your circadian clock. It's that orange, red tones and the blue tones of the sky. But right as the sun goes down across the horizon, especially over the ocean, there is the phenomenon known as the green flash.
Yes.
What is the basis for the green flash?
Well, I'll tell you something really cool. If you go to the South Pole, which is oversubscribed by a factor of 10 to 1, you believe 10 times as many people want to spend their 9 months of their year minimum at the South Pole than we have room for to actually do work at the South Pole.
Which means 10 people total.
No, there's 45 people there.
Just kidding. Just kidding.
And they're all listening to you half the time. When you want to go there, when you do go there, they actually don't know where the sun is going to set. Remember, the sun only rises and sets once a year, right? So it's 1 day and 1 night per year, 6 months long. Where the sun sets is unknown. And actually, the days preceding it, the sun is making a big circle around your head. I've seen this with the moon. So the sun and the moon, they just make a circle, and slowly after reaching their apex on the first day of summer, which is December 21st for them down there, upside down, eventually it crosses the horizon on March 21st. Around March 21st, that's the first day of fall, or when they start getting ready for winter. They don't know where it's going to go down. We think of it always going to the west, but where is west at the South Pole? Every direction you look is north, okay? So when this occurs, the actual phenomenon that you mentioned, the green flash, can last for days or can last for hours. So if you really are an aficionado of Huberman protocols and you want to see the green flash, apply to be down there. But the bad news is you're stuck there for 9 more months, okay? So yes, it's a real phenomenon. Not only can you take pictures of it, but you can see it with your eye. The only correction I would say is you pretty much need to have a perfectly clear day. You can't have any clouds on the horizon. And it's best seen over the ocean. So we're blessed here.
But for those of us that don't end up at the South Pole,
yeah,
God willing, send me pictures.
A lot of podcasts.
I don't like environments that cold.
Can really kill it.
But if I watch the sunset over the Pacific, or I see the green flash sometimes, what's the basis of that?
Yeah. So the Earth's atmosphere is actually it's layered, okay, but it's actually simpler to think about the Earth as being flat. Now, hopefully there's no flurfers out there thinking that Brian Keating is advocating the flat Earth. But imagine this table. We're looking at a table. Imagine there's a slab of translucent glass on it, and we're sitting on the table underneath the slab of glass, pretty thick glass, right? And you're looking straight up. You look through a minimum amount of the glass, right? Straight up would be zenith at your local horizon. Every direction you're looking is your horizon. You see off the edge of this flat Earth in this analogy. When you look at a slight angle, you're going through more path length of the substrate of the substance. More glass. Yeah. Finally, if you did have this thing extending to infinity, you'd be looking through an infinite amount of atmosphere or glass when you're tangent to the horizon, when you're going parallel to the Earth's surface in this flat Earth analogy. The Earth's atmosphere is not only made of oxygen, it actually has a lot of particulates. And it's because of those particulates, a lot of them come from dust, and a lot of them come from volcanoes, and a large amount now comes from human-made sources, pollution and so forth. The more optical depth, the more path length that you look through, the more scattering of the sun's light occurs. When scattering occurs, the longer wavelength light more easily penetrates through dust, smog particles, even glass. Okay, so that goes through easier. And the short wavelengths, comparable to the intermolecular spacing of the smog, the dust, the gas in the atmosphere, the oxygen, scatters much more efficiently. And so that gets scattered out of the beam of light from the sun. The sun's light, though, actually peaks slightly in the green. We don't actually notice this because our eyes and we're used to thinking of it as very yellow. It happens, and the reason for this can be substantiated by night vision glasses. What color is the light coming in? It's green, right? The amplified versions of these things. Why? Because your eye is very sensitive to green light. It's even more sensitive to green light than the yellow light. So, and that's because the sun, which is what we've evolved to adapt to, being most sensitive to sunlight, is more greenish than yellow.
So there's more power at the wavelengths, exactly. Like somewhere between like 450 and 550 nanometers.
Exactly, 100% right. So at that green flash, at that moment of green flash, you're seeing two things. One is the sensitivity of the human eyes, it's slightly maximized to that, but that doesn't explain why photographs see it as well. And the other reason is that most of the yellow light and the sunlight is getting scattered away, and so you're mainly seeing that green light, but you're only seeing it at the point of maximum scattering, which occurs exactly when the sun crosses the horizon.
Because of the interaction with all that atmospheric
dust.
Yep. That's wild, because for the longest time, I had a biological explanation for this that I think was based on a paper that was published maybe in Nature, but don't quote me on that.
Yep. Just because it's published in Nature doesn't mean it's wrong.
I've got friends with a few Nature editors still. In a great journal. Look, amazing. We do a whole episode about nature, science, and cell. But the explanation that was getting kicked around for a while was a biological explanation, which is that our ability to perceive reds and greens and blues and yellows is based on our trichromacy, the presence of these three different photoreceptors, short, medium, and long wavelength, or blue, green, red, so to speak, that absorb short, medium, or long wavelength light. And then the comparison, there's this opponency, whereby our ability to see red is really contingent on our ability to perceive green. And so for someone who's red-green colorblind, 1 in 80 males, for instance, they still see stuff out in the world that's red, but they see it as more orangish or brown.
Okay.
Dogs the same way.
Right. They're
not colorblind. True monochromats that don't see color are very rare. That is one form. I think it's called achromatopsia. Don't quote me on that either. But in any case, the idea was that if you're looking at something that's very enriched in long wavelengths, like orange, red, and you stare at it for long enough. Have you ever done that, like American flag visual optical illusion, where you stare at it, then you look away from it and you see the opposite colors.
Yeah.
right? And so one biological explanation is that the sun is setting, and you're looking at this orange-red thing. When the sun is low in the sky, you can actually look at it without distressing your eyes, right? Because
safe, yeah.
right, as opposed to overhead when you should never stare at the sun.
That's right.
And then the moment that reddish orange disappears, the biological explanation is that there's a kind of perception of a green flash because of the opponents in the switch to the other, let's just say, wavelength channel, so to speak.
I don't think that's in disagreement. I think that might explain the amplification that we see, but then it doesn't explain why you'd see it in a photographic emulsion, right? There's nothing biological about it.
I like your explanation better because
I think there's a
it's
part
explained by
physics,
real physics, and the biology of color opponency is also physics, but not as well worked out.
Yeah.
Okay, cool. Earlier, we were talking about the perceived relationship between the menstrual cycle, which is not always 28 days, but is on average 28 days, and the lunar cycle. Is there any evidence that, well, it'd be amazing if one influenced the other in the other direction, that the menstrual cycles were influencing the lunar cycle, but is there any evidence for a true relationship between the lunar cycle and the menstrual cycle that's been documented?
I don't know. It's interesting. The sun also produces tides and produces gravitational effect, but the dominant effect on Earth, due to that 28-day, 29-day cycle of the moon, is its effect on the Earth's oceans, which produces 4 tides a day, too high and too low. And actually, Galileo incorrectly used that phenomenon as a way to buttress his argument that the Earth went around the sun. He basically, if you're listening, I'm taking my glass of mattina.
Yerba mate.
Yerba mate, yeah. So he said that when the Earth is spinning, it rotates once per day, but it's also revolving around the sun. So these combined motions make this sloshing of the liquid. You see that? And he claimed that is what caused the tides on the Earth, when in fact that's completely wrong. It's amazing, Andrew, when you think about how brilliant a scientist can be. And it's almost like the proportion of their blunder is proportionate to how brilliant they are.
Because it also correlates with the height of the problems they're chasing.
Exactly.
You were saying that Galileo got certain things wrong, but got a number of things right.
That's right. Einstein too. Newton too.
Being wrong for the right reasons is actually very important in science. And by the right reasons, I mean that nobody's p-hacking, p-value hacking, or fudging data. That they're not tossing data. They're really trying to solve problems. And it's almost like in sports, a great competitor wants great competitors.
Yeah.
Right? I mean, why would somebody want to cheat into a different weight class, knock somebody out, and consider themselves the world champion at that weight class? It's silly. And in science, to not try and seek the truth is anti-science. Yeah. Certainly it happens, but okay, so no clear evidence that the lunar cycle influences the menstrual cycle.
I would expect that it would influence other animals. I don't know what the menstrual cycles are of, deer or whatever, who knows, or any animal that has, an egg that,
Well, a lot of animals have not a menstrual cycle, but an estrous cycle. So like a lot of rodents will have like a 4-day cycle.
Okay.
So it clearly doesn't map to the lunar cycle.
Yeah.
But you hear a lot about these things, and humans are amazing at drawing correlations. We're a prediction-making machine. We're a storytelling machine, and
And in the past, by the way, the moon was a lot closer than it is. Not a lot, but it was closer. The moon moves about the width of your, again, back to your fingers now. So the moon moves away by the width of about your thumb's fingernail every year.
Moves further away.
A centimeter away from the Earth, because there's a gravitational competition between the gravitational force of the moon and the Earth's oceans provide a source of friction. So over the years, it's getting farther and farther away, such that it eventually won't be able to have total solar eclipses. It'll be what's called an annular eclipse, where it doesn't obscure it completely. Anyway, so in the past, this is the only way to say, millions of years ago, when the first hominids were evolving, the moon was much, much closer. Millions of times of their fingernails. Eventually, it starts to add up. And certainly when the first life formed on the Earth, it was only, it was probably 30 times closer than it is now. So, yeah. So short answer, I don't know.
Where are some of the best places in the Northern Hemisphere, and please don't say the North Pole, where people can go see spectacular nighttime stuff?
Yeah.
So I think of Yosemite High Country in August for the meteor shower.
Yeah.
Certainly not at the level that you're accustomed to looking at things, but with the naked eye, you're going to be, assuming that it's not cloudy, you're going to be treated to a light show that is in my experience, beyond anything I've ever experienced. Just extraordinary.
On the special website that I made, briankeating.com/Huberman, I list the 4 major meteor showers, one in each season, that people can watch with your naked eye. In fact, it's bad to use a telescope. You don't want a telescope.
Because it juts through the field of view.
Yeah, exactly.
Right.
You want the whole field of view. And humans have an amazing, as you know, huge field, 190 degrees or something like that. Just not as big as an owl, but quite big. And you want to take that in because you're looking for motion, you're looking for intensity. Sometimes you can see colors, and I list what elements contribute to the colors of different meteorites on this, the website that I had. But yes, the anywhere that's more than, say, 20, 30, 40 miles away from a major city is fine. Even in San Diego, there's 2 dark sky communities. One is called Julian, California, and the other one's the Anza Borrego Desert. It's called Borrego Springs. These are areas where they forbid upward shining light. So the only light can be downward facing. It also has to have very narrow spectral bands on it. So like sodium vapor, very high, so that you can filter it out basically with certain very inexpensive optical filters. But, like I said, almost anywhere. But the good thing to know is that if you get a telescope, again, you can see 90% of what's going to be fascinating to you as a lay person with a telescope that costs $50. You can see all the craters, you can see mountains on the moon. And again, these mountains were not just like cool things. They they falsified the scientific paradigm, quote unquote, which was that the moon was perfectly crystalline and spherical. Galileo showed, no, not only does it have mountains, I can measure the height of those mountains. I can measure the planes of lava flows. And eventually they came up with theories that it doesn't have tectonic motion. It doesn't have an iron core. I mean, it's amazing. You can see all these things with the small telescope, like the one I have for you. But you don't need like the Hubble telescope or Mount Wilson. You don't need any of that. You can see the rings of Saturn, the moons of Jupiter. You can even, on a dark sky without a telescope, see an object that's outside of our galaxy. It's called the Andromeda Galaxy. It's very important in the history of astronomy. In 1923 on Mount Wilson, not far from here, Edwin Hubble realized that was not part of the Milky Way galaxy. It was way too far away to be located within the Milky Way. It was about 20 times the radius of the Milky Way. And that revolutionized all of our conceptions of where the universe is located. Is it centered on us? Are we the most important thing? No. He showed that you can see that on most fall nights in the constellation Andromeda with your naked eye. It's 6 times wider than the full moon. It's incredible.
When I look at many of the constellations, I don't see how our ancient predecessors got to the description of a bear or whatever. Is that because they saw more stars than I did? Or is that because they had a wilder imagination? Again, or were taking psychedelics or something
20
like that?
centuries before TikTok. So I cut them some slack. There are a couple that look similar to what they're, Orion.
But it depends on how you connect the dots.
Yes.
I mean, the Big Dipper and the Little Dipper are kind of like, okay, you get that.
Those aren't constellations.
Those aren't constellations.
I have to be
great.
I have to put on my very, very precise.
Why are they not constellations?
So they're portions of a constellation. So they're called asterisms. So an asterism is a collection of stars that's associated with each other, but it's not the full composition of a constellation. So the constellation is actually called Ursa Major. The Big Dipper's in the tail and the hindquarters of Ursa Major, which is the Great Bear. The Little Dipper is the asterism, 7 stars that make up, there's 80-something stars that make up the Little Bear, which actually doesn't look like a bear. Ursa Major kind of does look like the California Republic flag that we have. But yes, the asterism, I always ask for people to leave. You can't, they're not making new constellations. There's only 88 constellations over the whole 4-pi spherical dome of the sky. But you can leave your own asterism on the podcast. You can leave 5 stars on your podcast and mine. So you can't have a constellation, but you can have an asterism.
Love it. Did you catch Halley's Comet when it came by? When you were a few years older than I was?
I was 14. It was right after I got my first telescope.
Comes through every 70 years.
You're making it to the next one. 76 years. Yeah, that's right.
I'm right.
Yeah, that's very good. Yeah,
I remember 70 something. All right, but.
It's not like the best constellation. It's not like the best comet in history. In fact, there's better ones.
Yeah, I remember going out to see it. It was a part of a group that went camping, and it looked like a smear of light. It's hard to know. Did I really see it, or did I not? In any case,
your dad, you probably.
The only other comet that came to mind. Is the San Diego thing? Was the Hale-Bopp?
Hale-Bopp, yeah.
Where there was a group that committed mass suicide.
Yeah.
Yeah, these were people that had castrated themselves, had been eating a sub-maintenance caloric diet to live forever, and then decide to wear Converse and kill themselves.
Yeah.
What do you think? Well, let's not go dark there. What do you think is the relationship between like comets and these wild human behaviors?
It's so interesting you mentioned that.
And lunacy, for that matter, like full moon and lunacy.
Right.
You know,
crime statistics. So look at these words: disaster, catastrophe. They asked in both of those means star. They used to believe that stars, comets, eclipses, those things were influencing events on Earth caused by these celestial forces for not propitiating them, making them gods happy or whatever. And in fact, Columbus owes his life, he was almost killed in Jamaica. And I think it was 1498, a couple of years after discovering Jamaica. He's still exploring. And he was failed to ingratiate himself with the local, native inhabitants of Jamaica or wherever he was. And they were going to kill him. And he luckily had on for navigation. Astronomy and navigation have always been intimately related because, first of all, if you know where Polaris is, which is not the brightest star, it's in the Little Dipper. It's the pole star. It's the North Star. You've heard of True North, North Star. It's actually very close to being, if you go to the North Pole and look straight up, it's very close to being directly above you.
And does it always mark true north?
In any human time scale, it does. Over thousands and tens of thousands of years, it changes. But right now, for the next couple thousand years, so don't worry, you'll still be accurate. That is within a half a degree or so.
That your brain thinks at these time scales. As long as you're talking for the next 1,000 years, you're good.
Well, I say it like this, the universe could end in a heat death and a big rip or whatever, but that's not for 1 trillion years. So everybody keep paying your taxes. So you could use it for navigation. So you could know your latitude, but measuring longitude was very difficult because you couldn't actually, to know longitude, you need to measure time relative to where Greenwich Mean Time is. That's how Greenwich became so important, and that's why London had its huge economy. Again, these things are always related. Capitalism and even how we measure latitude and longitude comes from the fact that London and the Thames River, 90% of the world's commerce flowed through there at one point or another. It's incredible. So anyway, latitude, longitude is very important. People started to know that, these events would occur, and including this event with Columbus, and he brought along with him on his voyage an astronomer. And this astronomer knew that in 2 days' time from when these natives had captured some of Columbus's crew, that there was going to be a total solar eclipse, and it was going to go through Jamaica. And he told Columbus, and Columbus said to the inhabitants, if you don't give our people back, our God is going to obscure and kill your God, the sun god. And they're like, F you, whatever. And then it happened, and they totally believed that they were in control of these celestial events. We better give the people back. And Columbus got the hell out of there. Whoa. So it's an amazing story. But yes, comets have always been
So Columbus actually used the sun as manipulative barter to
threat
as a threat.
Military, he used it for military coercion.
An important book for anyone to read who's interested in basically why we're still here, in my opinion, is the book Longitude.
Yes, I'm interviewing
by Dava Sobel.
I'm interviewing her tomorrow.
This is an incredible book. Yeah. Doesn't require any science or technical background to read and appreciate about the development of the first reliable timekeeping devices for navigating at sea, even on overcast nights, and longitude and finding longitude. It's a spectacular read.
It is,
and changed the way that I think about human evolution and technology development generally.
There's a direct connection. Sorry to interrupt, but there's a connection between that and the Nobel Prize. So there was something called the Longitude Prize in the 1700s. To develop a clock that could be used in the naval situations on boats. You couldn't use a grandfather clock as the pendulum acceleration. So they had to find something, and this guy, Thompson or somebody. Harrison, yeah. So he invented this mechanical clock, which predecessor of our modern wind-up clocks. Obviously, we use cesium and atomic clocks. But that prize for 10,000 pounds or whatever it was an early predecessor of the Nobel Prize.
I've been waiting this whole conversation to talk to you about adaptive optics. Let me give just a little bit of backdrop for how I'm approaching this. In the field of neuroscience, there's, as with any field of biology, a desire to see smaller and smaller things at higher and higher resolution. And there have been all sorts of incredible discoveries in microscopy, like 2-photon microscopy, 1-photon microscopy, electron microscopy. You see things down to the tiny, tiny nanometer size. Some years ago, a group out of University of Rochester developed adaptive optics. I think it was David Williams' group, which is borrowed from astronomy. And my very top contour understanding of this is that you're using the presence of noise in the environment, essentially, as part of the microscope to get a better image. And this was used in the field of ophthalmology to look into the back of the eye, this incredible 3-cell layer thick pie crust that lines the back of our eyes, that it gives us all of our visual perception, not alone, but allows for all of our visual perception. As I mentioned before, the eye has a lens, there's vitreous, there's all sorts of opportunity for light scatter. And then within the eye itself, you've got these multiple layers you have to go through before you can see the photoreceptors. But using adaptive optics, you can take all that noise, all that stuff between the microscope and what you want to see way, way back in the eye, and use that, in air quotes here, noise, and make it part of the microscope, so to speak. And without going into further detail there, I was always told that adaptive optics was borrowed from your field, astronomy, where people used the presence of atmospheric dust, of these stuff in the way, and made it part of the lens, if you will, to be able to see things at higher resolution, which I just think is so incredible. It's like saying the barrier becomes the portal through which you can see even more than had you had a clear path.
The obstacle is the way. Let's shout out to Ryan.
All right, shout out to Ryan Holiday. Never met him, but I like that book very much. Yeah, okay, so what is adaptive optics at the level for astronomers?
Okay, so we live in an atmosphere, a planet with an atmosphere. Thank God, we wouldn't be here having this conversation, right? And that atmosphere is a dirty window. It's like literally looking through the windshield of your car, and it's cloudy and dusty and contaminated. We live in its presence. And the best astronomical telescopes are the ones that are launched above the atmosphere, out of the atmosphere. Hubble Space Telescope, Kepler, and now the James Webb Telescope. Again, those are multi-billion-dollar telescopes. The James Webb, to build it, and by the way, one lesson to leave you with, and maybe your audience with as well, is whenever you hear a scientific instrument's cost, always in your mind at least double it. So Andrew Lang, my late great mentor, used to say multiply by pi, because you're not taking into account the fact that you don't build, say, a destroyer or an aircraft carrier to build it. You build it to use it. And it's about 10% of the construction cost to operate an instrument, a battleship, a telescope, whatever. It's a rule of thumb that project managers love to use. So that means in 10 years it's going to double the price. And we hope that Hubble and Webb, and Hubble's already lasted 40 years on it. So it'll last a long time. So whenever you hear this, but it's incredibly expensive. 1 kilogram used to cost like $10,000 to bring to orbit. And Elon keeps talking about how cheap it's going to be, $500, but he has yet to launch a scientific instrument. I talked to him for 10 minutes on my podcast once, and I tried to get him to shut off these. Starlinks are amazing. I have one in my house, but they have the property that they go through astronomical images and they leave a satellite trail behind them, which is can be comparable. You're taking a picture of a deep star, a deep galaxy or whatever, and you see these streaks going through it. It ruins the image, and you have to wait until they're gone. But at least in optical astronomy, you can physically, literally paint those satellites black, and they will no longer reflect, and so they won't obscure the image whatsoever.
So you're saying that the Starlink satellites are going to make your job more difficult?
They definitely are, because while you can paint an optical satellite black and make it black, we're looking for heat. There's no way to stealth, confuse or block out heat. Sorry, that's a law of thermodynamics. Anything that's above absolute zero will always give off heat. And worst of all, the signals that he uses are in the exact microwave spectral range that we use to look at the CMB, the cosmic microwave background.
So what's his response to this?
I told him that
having internet everywhere is more important.
No, he said he would look into it, 9 months ago. Elon, I know you like the show, so please do reach out to me. But this would be just turning it off when it's over our telescope, basically. That's what and the South Pole. Yeah. So it's not a big deal.
You have a specific request.
There's no one at the. It's not like he's getting millions of dollars in ad revenue from people at the South Pole. They don't use them. So anyway, that's I'm asking Elon. It's a small ask, but anyway, so we want to be above the atmosphere, but it's millions, maybe billions of dollars to do that for a telescope like we're using, or for an optical telescope here on Earth. So scientists became very convinced that there has to be a way to mitigate the effects of the atmosphere. Now, what is the main effect of the atmosphere? Well, you learned it when you were a kid. Twinkle, twinkle, little star. How I wonder what you are. What is that twinkling? It's called scintillation. Scintillation is the property of a point source which is a star is so far away, even though they're enormous, they still only subtend a almost zero-dimensional dot of light on the sky. When it goes through the atmosphere has macroscopic turbulence features. The atmosphere is a fluid. There's turbulence, there's roiling columns, there's cells of the atmosphere. And if you've ever looked at a star, they jitter, they looks like they're moving around. And that's the combination of the atmospheric cells. Each column of air that has slightly more density will refract light slightly different angles. Remember we talked about light when it goes through a lens, it refracts, it bends.
So should we be thinking about the light from stars kind of like a jagged line coming towards our eye?
It's coming through, it's getting deflected slightly, and it's moving in, and it's landing on different retinal cells. And we're perceiving that as this motion, or in a CCD array, it's also landing on different pixels. So you can't get away from it, by using technology. It's still an effect. It's caused by these atmospheric turbulent cells. And by the way, you can tell and you can identify a planet by the fact it does not scintillate. It does not twinkle. So Jupiter's visible tonight. I hope you'll see it with the telescope. We can see it after we're done recording. We'll keep going. We're about halfway done, I figure. We'll go outside, we'll look at it, and you'll see it's stationary. And I actually used that on the night I kissed my wife for the first time. But I'm not going to talk about that. When you look at the planet, you can identify them by their lack of scintillation. So it's a way to identify if it's a plane, a star, or a planet. So astronomers, including a colleague of mine in the UC system, Claire Max, and other people, realized in the 1960s and 70s that if they had a fake star, it's actually called either a guide star or an artificial star. I'll explain how they make that in a minute. Then if they knew the exact properties of that guide star, then they could measure just the guide star through the same optics of the telescope, and then they would take the light from that artificial star onto a flexible, deformable mirror. So the mirror could actually wobble and wiggle, and it would do so in an exactly compensatory way to nullify the atmospheric turbulence. So it's basically what light does when it goes through a cell of the atmosphere. It traverses a slightly longer path difference. So they would shorten the path difference of the mirror. They make it a little bit closer in the direction of that cell, and other places they'd make it farther away, and vice versa. They compensate for it. And this was done by a combination of two technologies. One was the deformable mirror that could flex 100 times per second. And the other was making these artificial stars. So how do they make an artificial star? They shoot a laser into the troposphere. That laser illuminates sodium.
What's the troposphere?
Troposphere is a layer of the atmosphere. I used to know all the different layers, but
that's okay.
Okay, ionosphere is the farthest away.
So some layer of the atmosphere.
Yeah, it's 40 kilometers above the Earth. It's not quite in space. Farther enough away that the laser beam is still collimated. It makes a nice beam, and it can illuminate and then cause this sodium ions to fluoresce, basically. So they start to get really stimulated. It looks just like a star. They know exactly how they produced it. They know exactly what phase and wavelength to correct in the mirror. And then they say it's almost as good as going into space. It corrects exactly the compensation of the Earth's atmosphere with the combination of this deformable mirror. And it was actually used by my colleague Andrea Ghez here at UCLA to measure the properties of stars orbiting around the black hole at the center of the Milky Way and test Einstein's theory of relativity. Without this, on the twin 10-meter diameter Keck telescopes in Hawaii, she never would have won that Nobel Prize. So it's amazing technology, but it was classified. It was so useful to astronomers, but it wasn't as useful as to the military. Remember, I said Galileo used his telescope to sell it to the military of Venice. It was immediately classified by the U.S. military because if you think about a spy satellite, what's it doing? Well, it's staring down to Earth, and it's looking at looking at whatever on Earth. It's also going through the atmosphere. It's going to have the same problems. So they wanted to use that and have this technological advantage over the Soviets, probably in the 1970s and 80s. So they classified it. They didn't let many astronomers could build things. They could deliver the finished product, but they couldn't patent it. They couldn't use it. And so Claire Max, as I said, she could have been super rich. But it's interesting because now they're using it. It's bad enough to look, from Earth to space. But as I said, if you imagine the Earth as having a slab of an atmosphere, imagine a sniper. The sniper's trying to make a kill shot. Jocko's out there trying to hit something 5 kilometers, 3 kilometers away or whatever. There's a lot of atmosphere in the way. And if you're looking through an optical sight, that will also happen. So now they're actually using this optical compensation, and sniper scopes are using this technology, adaptive optics. So it's another way that astronomy has influenced military developments as well.
Very interesting. I don't want to go too far down this rabbit hole, but I'm aware that there are some technologies now to use lasers to extract sound waves in a similar way. So there are technologies that exist where you can shine a laser at, say, a window on a building from very far away and actually hear the conversation inside the room by way of the sound waves hitting that window. The conversion of sound waves to optical and then from optical back to sound on your computer allows that. Also, there was a technology that was publicized a few years back, developed at least in part at Stanford, the ability to see around corners by shining lasers at the most visible location closest to what you want to see, and then capturing reflections and sound waves at that location and essentially being able to reconstruct images around corners, see how many objects are there. So pretty wild stuff. You can imagine the military and spy implications, but also but perhaps just as interesting, the ability to, for instance, map the positions and movements of critters in the deep ocean without actually having to quote unquote see them. You could hear them. I had a really interesting experience a few summers back of going to somebody's pool. It was an impressive pool, but the most impressive thing about it was that you could hear music perfectly well underwater. Using adaptive acoustics.
And listening to your episode with Goggins.
No, it's wild. You could you listen to something above water, dive below water, and still hear it as if it were playing in headphones. Maybe not quite as well as in headphones, and if you sloshed around in the water, there'd be a little perturbation, but it's pretty spectacular. It wasn't my pool, unfortunately. I have one big question that I think everybody would like the answer to, which is, to what extent do you think there's life outside Earth or not on Earth? And when people hear this, they think aliens, but like an insect-like creature, single or small multicell organism on another planet, that itself would be a spectacular find. I mean, beyond spectacular. Is there any evidence that does exist? Is there any reason to think that it couldn't exist? And if it does, would it have to be in a different galaxy altogether? What's the going belief among those who are like real scientists who don't believe that there's just real scientists? Like what's the thought? A centipede on Mars? I don't think too many people would be totally surprised. They might. But that'd be pretty wild.
Well, I'm kind of an outlier, so just everyone should look to the actual experts in this field. But I have some rigorous, kind of logical arguments that I believe the probability of life, I would never say it's zero, but I think it's very low. And I think I can substantiate that. And the best part is I can't be falsified right now. There's zero evidence that there's life anywhere else in the universe, period, full stop, end of sentence. There's no evidence, conclusive evidence. In fact,
lots of drones over in New Jersey right now, no evidence of life anywhere
knew we'd
else.
Get into drones. So the argument that it would somehow, first of all, transform our understanding of human place is inarguable to me. I believe that's true, although in this movie Contact is a really wonderful movie. It's not cheesy science fiction. It was the first to use a wormhole and all sorts of cool stuff as contrivances. But in that movie, there's a scene where President Bill Clinton is talking about the discovery that this fictitious character made. But he's actually talking about a meteorite that was discovered in Antarctica, and they just clipped that. And the meteorite was believed to have microbial life, and that meteorite's origin was inarguably from Mars. Okay, so the reasoning was, this is 1997, that there was a meteorite found in Antarctica, where it's easy to find meteorites.
Is it in the movie or in real life?
This is in real life. In 1997, a scientist announced the discovery of a meteorite from Antarctica. It's called Allen Land Hills meteorite. And it had what they claimed were evidence of microbial life and even respiration byproducts of these microbial life forms, okay? It was such a big deal that within minutes, Bill Clinton had a press conference on the White House lawn where he goes, "This rock speaks to us from across the generations, and if confirmed, will undoubtedly, revolutionize our understanding of the universe around it." Okay. Now the movie clips that clip to make it seem like Ellie, the fictitious character, discovered SETI, extraterrestrial technology, not a microbe. But in the public's mind, that actual scientific discovery was never falsified. It was certainly never confirmed. No one's ever come back to say that was correct and that we did find microbial evidence of microbial life on Mars. Now, how did that meteorite get there? Well, some asteroids hit the moon. That's why it has craters on it. It hits the Earth. That's why we have Meteor Crater, Arizona, and Winslow, Arizona. Yucatan, Chicxulub, where the dinosaurs' doom was sealed by the giant impactor 66 million years ago. Those impacts occur on every planet, every moon in our solar system. So some asteroid hit the surface of Mars probably millions of years ago, ejected material, low gravity on Mars, low atmosphere, and that material has been orbiting around and eventually made its way and hit the Earth. Okay, so matter from Mars landed on the Earth. Does that make sense? Mm-hmm. That's how I have a lunar meteorite that I'm giving to you, again, as a token of my appreciation for all you do. That came the same way. Something hit the moon, blasted off some lunar, it's called breccia, it's the crust of the moon, eventually made its way, landed in Northwest Africa, and I bought a slice of it from I got a dealer, I got a meteorite dealer, and got that for you, okay? So what's the lesson? Material gets exchanged from planet to planet. Now, I asked the following question. If that happened on Mars to the Earth, the Moon to the Earth, so too has material from the Earth been ejected since life emerged 3.7 billion years ago. There's literally millions of tons of Earth that's floating around in space. Some of that will have landed on Mars. So someday we'll get there, we'll find some piece of it. Now, could some of it have a tardigrade on it? Could some of it have a protozoa on it? Obviously it could. And
maybe some interesting microbes.
Yeah, it could.
Maybe some ancient microbes that are no longer
That's right.
extant.
Yeah, it could. It could have, what's an adaptogen? I have no idea.
An adaptogen?
You talk about adaptogens.
Adaptogens it's a broad term used to describe any compound that allows you to modulate the stress response. So maybe increase your stress threshold or recover from stress more quickly. It's sort of like saying stimulant,
it's not
adaptogen, sedative. No, it's a broad category.
Yeah.
I mean, I think, some people say like certain non-hallucinogenic mushroom strains are adaptogens. I mean, the ability to buffer the stress response.
Interesting.
I mean, things like rhodiola have been described as adaptogens, and these work through neurotransmitter systems. So broadly speaking, they allow you to perceive effort as less effortful, this kind of thing.
Okay.
Yeah.
So one theory of the formation of life on Earth, you asked me about that earlier, the origin of life on Earth is a huge mystery. How did life get here? One proposition was made by Fred Hoyle and other people. It sounds dirty, but it's not. It's called panspermia. It just means that genetic material has been transferred from another astronomical object landed here on Earth. So the converse reaction occurs as well. But the fact is we don't observe it even on Mars. So if I told you, we've discovered a planet and there's another planet right next to it and it has almost the same conditions. It's in the so-called Goldilocks zone where the temperature is just right to have liquid water, which Mars can have on it at certain times of the year in certain places on Mars. It had flowing water on it. We know for sure Mars had flowing water on it. We know for sure that material from the Earth got there when Earth had life on it. So the absence of life on Mars is a data point. It's not probative or provative, or it's positive rather, that life couldn't exist on Mars. We haven't searched all of Mars. But it at least shows that there's an impediment to it. So people are fond of saying, as I told you earlier, there's about 10 to the 24th planets probably in our observable universe, going back to the Big Bang, going out to the farthest reaches of the universe. But even if you just take the Milky Way galaxy, there's probably, literally hundreds of billions of planets in our galaxy alone. And when you look at that, people like to say, as Carl Sagan did, if there's no life, it's an awful waste of space, right? Why is there so much space and there's no life? It seems incomprehensible. But nature, I love when atheist scientists will say, like, you propose God exists and that's the God of the gaps to explain things that you don't understand. But when science advances, we'll have an explanation for why, thunder occurs. It's not because of Thor, right? We get rid of gods as we learn more. And so the God of the gaps shrink smaller and smaller. But they'll say the same argument about life in the air. They'll say, well, there's got to be life because there's so much room there. But as I told you, I've been to Antarctica twice. The only life forms I saw there, were people. I saw a few penguins in the distance and a couple of dead sea lions. There's no trees, there's no flora at all on the entire continent. It's incredibly barren. And yet, Andrew, it makes up 8% of the landmass of the Earth.
Wow.
And you would think, well, if it's just proportional to the amount of area, i.e. the number of stars, there should be 8% of the life on Earth. There should be a billion people there or whatever, 600 million people. No, there's nothing there except for scientists that go there. So the odds of life, you can't construct probability from possibility. and many, many other arguments that I could give you, the improbability of life, how hard it is to create life. And, if you just sprinkled, imagine you had a koala cannon, okay? People at PETA are going to get mad. Imagine you just go to Mars and spray it with koala. I mean, it's obviously not going to
Well, I think
start
PETA
life,
would
right?
probably be okay with you populating with an area with koalas. A cannon to take out koalas, they would probably protest.
That's right. They would not like that. So possibility is not probability. The number of hurdles to create a single cell is enormous. We have yet to reproduce, to make a functional cell in the laboratory. Not that that's a requirement to prove that life could exist elsewhere. Just saying it's very hard. Our history of life, we have an N of 1. It's very difficult to speculate on. And if we're alone, if life is abundant, as Fermi asked many, many, many years ago, if life is abundant and the galaxy is old, where are they? Where are the aliens? There should have been plenty of time, not only for them to evolve and be superior to us in many ways and travel the distances of our galaxy, not even of the cosmos, of our galaxy. Where are they? Where are they? They've known about us for 80 years because we've been broadcasting radio waves for the last 85 years.
Do you know this theory about the gut microbiota?
No.
Our guts, our skin, our eyes,
Right.
our nose, but certainly our entire digestive tract, the whole way down from our lips out the other end, are populated with these little microbiota that influence everything from fatty acid production, neurotransmitter production, et cetera.
It's more than human cells, right?
Yeah. Oh, yeah. And it's powerful for modulating all sorts of biological processes. And every time we interact, shake hands, if people kiss, if you interact with dirt, if you interact with a pet, the microbiome changes. It's an inner reflection of all your outer behaviors.
And internet, yeah.
Yeah, and then we're learning a lot about it. There's this one theory that I like that kind of turns life as you and I know it on its head, which is that humans and other species are just vehicles for the microbiome. And that, and so you would take something like, the desire to populate Mars or to shoot or to land on the moon as just the microbiota, taking advantage of this weird old world primate species that we call Homo sapiens that loves to develop technology, almost destroy itself, but then continues to evolve, social media, et cetera.
Actually, yeah, Kim Prather
warn each other about declining birth rates, and then just to basically the microbiota have a sort of quote unquote consciousness, not a brain, but a consciousness of their own, which is like all species, to make more of itself and to go further and further out and populate. It's hard to punch holes in the logic of this model, but it certainly diminishes our conscious experience. We could go on forever about this trail. I'll just kind of put a kind of a cliffhanger out there. It'd be wonderful sometime to sit down with you and discuss the possibility of, rather than thinking about life elsewhere in the galaxy, given what we know about physics and engineering, astronomy, et cetera, would it be possible to build a planet at the appropriate distance from the sun that we could spawn life by bringing things there, as opposed to trying to take it, figure out how to do it at a distance that it might not be amenable to life?
Right.
Maybe creating a garden planet. Maybe we don't put humans there right away, but trying to create a garden that could thrive at some appropriate distance from the sun.
Yeah.
And seeing what nutrients could be grown there. So you could have robots man this planet, but you'd have to somehow aggregate stuff in space to build this planet or launch this planet up, that it would collect things. I mean, that to me feels like a fun experiment.
It is, yeah.
And a lot less risky than going up to other planets.
I was blessed as my first guest on the Into the Impossible podcast to have Freeman Dyson. Now, you mentioned with your dad mentioned him. One of the greatest intellects of the last 100 years, great physicist, and he had these ideas for these Dyson spheres, which would be energy harvesting. So the first ingredient that you need to construct the Huberman planet habitable zone is to have energy. It harvests as much energy as possible from a star. So he basically conjectured a megastructure, an alien megastructure that could be observable by astronomers could detect these objects, and some have claimed that we have, but those have always been refuted. And it would be basically surrounding a star, capturing every photon worth of energy that came out of it, and then converting that to mechanical energy. And then, once you have infinite energy, you can actually do fusion. You can make up whatever molecules you want. You could make up, 3D printing at the quark level on up, basically. And so that was his, conjecture of how super advanced aliens would behave. But again, we have no evidence for it, but it's fun. It's certainly fun to have the science fiction, kind of a lot of interesting science, originates from ideas and creativity that originates from science fiction. So yeah, it'd be a lot of fun.
You and I could talk about the stars, the planets, optics, animals, life here on Earth, infinitely. This is what happens, folks, when two real nerds get together and want to learn from one another. And I hope you delighted in this at least half as much as I did. Those of you listening, you occupy an incredible place, and I mean that. Like your intellectual place since you were a child is a remarkable place that most people, I think, don't occupy. Not because they don't have the training, but because they just haven't put their mind on these questions. And I think one thing that's so clear is that through your podcast, your books, and certainly through the discussion today, you've placed us in the position of scientist to be able to ponder these really big questions about really big, really distant things. This is not typically the way that my brain functions. I think most people are more focused on things proximal to them and here on Earth. But I'm so grateful that you did, and I'm so grateful that you continue to educate. We didn't even get to talk about, but I'll just mention that you've been a absolutely spectacular proponent for popular science education and the importance of that. I've been very inspired by you and your work.
Thank you.
Very inspired by your story. Sure, because of some similarities and, fathers and sons and the tribulations, et cetera, different, but some overlap there. But also just because of the way that you approach life. And it's very clear to me that as a person who's focused on things very, very far away, where apparently there's no observable life yet.
Not yet.
That you're also very grounded in this thing that we call daily life and the delight of exploration and asking questions. And if ever there was a call to arms for people to get outside and look at the stars, perhaps through a telescope or perhaps through the telescopes on the front of their skull, certainly to do that and to think about some of what was discussed today, because I'm certainly enchanted, and I know those listening and watching are as well. So thank you for everything you do. Keep doing it. Come back. Let's keep talking. We didn't talk about God and the universe and the origins of life, but we'll do that before long. And Brian Keating, thanks for being you. I appreciate you.
Thanks, Andrew. You've been a big inspiration to me too. And, use your language. Thank you for your interest in science. It's really done so much for the world, and you give it all for free. And it's truly an inspiration. And it's really fun to talk to somebody who's, at the level that you're at in so many different things and still has that, as scientists, we get inured, we get kind of used to things. Oh, there's a rainbow, there's a meteor, whatever. But you still have that passion. You have that passion, that curiosity. And I think that's what makes a true scientist. And the function of education seems to beat that out of kids. But really to have that in the domain and the expertise that you have is a real inspiration. And I think it's a huge service to society. So I want to thank you too.
Oh, thank you. Well, it's a labor of love mixed with an affliction. So we'll keep going. Right back at you. Thanks, Brian.
Thanks, Andrew.
Thank you for joining me for today's discussion with Dr. Brian Keating. I hope you found it to be as informative and indeed fascinating as I did. To learn more about Dr. Keating's work, his podcast, his book, and other resources, please see the show note captions. If you're learning from and/or enjoying this podcast, please subscribe to our YouTube channel. That's a terrific zero-cost way to support us. Please also click follow for the podcast on both Spotify and Apple. And on both Spotify and Apple, you can leave us up to a 5-star review. Please also check out the sponsors mentioned at the beginning and throughout today's episode. That's the best way to support this podcast. If you have questions for me or comments about the podcast, or topics or guests that you'd like me to consider for the Huberman Lab podcast, please put those in the comments section on YouTube. I do read all the comments. And if you're not already following me on social media, I am Huberman Lab on all social media platforms. So that's Instagram, X, formerly known as Twitter, Facebook, Threads, and LinkedIn. And on all those platforms, I discuss science and science-related tools, some of which overlaps with the content of the Huberman Lab podcast, but much of which is distinct from the content on the Huberman Lab podcast. Again, that's Huberman Lab on all social media platforms. For those of you that haven't heard, I have a new book coming out. It's my very first book. It's entitled Protocols, an Operating Manual for the Human Body. This is a book that I've been working on for more than 5 years, and that's based on more than 30 years of research and experience. And it covers protocols for everything from sleep to exercise to stress control, protocols related to focus and motivation. And of course, I provide the scientific substantiation for the protocols that are included. The book is now available by pre-sale at protocolsbook.com. There you can find links to various vendors. You can pick the one that you like best. Again, the book is called Protocols, an operating manual for the human body. And if you haven't already subscribed to our Neural Network newsletter, the Neural Network newsletter is a zero-cost monthly newsletter that includes everything from podcast summaries to what we call protocols in the form of brief 1 to 3 page PDFs that cover things like how to optimize your sleep, how to regulate your dopamine. We also have protocols related to deliberate cold exposure, get a lot of questions about that, deliberate heat exposure, and on and on. Again, all available at completely zero cost. You simply go to hubermanlab.com, go to the menu tab in the top right corner, scroll down to newsletter, and enter your email. And I should mention that we do not share your email with anybody. Thank you once again for joining me for today's discussion with Dr. Brian Keating. And last, but certainly not least, thank you for your interest in science.